Preface of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lauren Huff. Elements of Conchology by William Ruschenberger. Preface. The fifth of the series of First Books of Natural History embraces that branch of our subject which treats of the mollusca, or soft animals, and consequently includes the elements of conchology. In the beauty and singularity of their forms, the variety and brilliancy of their colors, shells only yield to flowers. The admiration of these deserted habitations of a very numerous class of animals is very general, if not universal. Scarcely a house, at least in seaport towns, is without a few shells, and in many there are large collections of them. Comparatively few persons, however, view them in connection with animal existence. For the mass they are merely beautiful things from the seas and rivers, far and near. We care little how they grow, how they live, how they breathe, upon what they feed, or for what use they were created. Who stops to think an oyster has a heart and blood vessels, a breathing apparatus, a nervous system, or digestive organs? How very few are aware that certain snails possess eyes and lay eggs? Nor is it universally known that we are indebted to the organization of soft animals for mother of pearl and pearls. Limited as this little volume is, it may prove a key to stores of information, even more interesting to many than the numerous fictions of the day. Truth is stranger than fiction has been often said, and the beautiful truths brought to us by a study of animal life in its various forms are certainly more admirable and wonderful than any fiction of man's creation. Is there any thing produced by the Bulwers or the Jameses of the day more worthy of admiration than the habits of a snail or the movements of a cockleshell? When at the Sandwich Islands, in 1836, we heard an anecdote which has an application here. The officers of a British ship of war manifested a strong desire to obtain curiosities. A young Kanaka, with a view to profit, brought to one of these officers a chicken's foot, and offered it for sale, and by way of insisting upon its value said, as he pulled the tendon which was attached to its toes, "See how nicely it works." And was it not more worthy of attention and thought than all the idols of wood and stone that could be collected? Fictions are the works of man, but the wonderful truths of the universe are the creations of omnipotence. Yet we bestow more time and more interest on the last novel, in many instances, than would be sufficient to lead us to the contemplation of all the beautiful and magnificent productions which it was Adam's duty to name. Whoever reveres his God should be able to contemplate his works understandingly, and be able to perceive the beauty of design, the adaptation of the organization, the various forms of life, to the circumstances in which life is placed, and perceive the same wise hand in the structure of the snail, as in the complete and perfect animal, man, and learn, too, that even an oyster is within the scheme and protection of Providence. In forming this little volume, besides the work of Messrs. Edwards and Comte, those of Cuvier, Lamarck, Blainville, and Captain Thomas Brown have been consulted and freely used. Many of the engravings are copied from the work of Monsieur Blainville, and it is believed the engraving, which was done by Mr. G. Thomas, No. 37, South 3rd Street, will compare favorably with anything of the kind ever offered to the American public. The etymology and pronunciation of the technical words have been placed at the foot of the page. This little volume offers the means of becoming acquainted with the history of soft animals and conchology, and opens the way to an advantageous perusal of more complete and ample treatises on the subject. Philadelphia, June 1st, 1844. End of Preface. Recording by Lauren Huff. Lesson 1 of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lauren Huff. Elements of Conchology by William Ruschenberger. Lesson 1. General considerations. Mollusca in general. Organization. Nervous system. General form. Skin. Mantle. Shell. Formation of shell. Digestive apparatus. Circulation of the blood. Respiration. Senses, eggs, classification. The long series of vertebrate animals, the history of which we have already concluded, forms only a small part of the animal kingdom, and to make the beings we are now about to study as interesting as the vertebrata, we should be obliged to very far exceed the limits of these lessons. But these animals are less useful to us. They attract less attention, and most of them pass unnoticed, except by those who are at the pains of becoming acquainted with them. Their faculties are more limited, and their structure is less complicated and less perfect. All these lower animals want a spinal marrow and a true internal skeleton. This last character has obtained for them the collective name of invertebrate animals, but in a natural classification they could not all be placed in the same group, because they are evidently formed after 3 different types, and therefore should be divided into 3 distinct branches, namely, the mollusca, the articulata, the radiata, or zoophytes. The branch of zoophytes is composed essentially of the most imperfect animals. According to the classification of Cuvier, which we follow, this branch comprises a certain number of beings which seem in a manner to present the first sketch of the mode of organization proper to mollusks and articulate animals. Its place is therefore among the lowest grades of the animal series, and passes, by gradual shades, from the type of the radiate animal to that of the 2 great branches which spring from it. These 2 latter branches, one equally with the other, present a constantly increasing complication of organization, and form, as it were, 2 parallel series. The series of articulate animals seems to be the highest in the scale, but the mollusca, though less perfect in structure, seem to be less remote in their mode of organization from the vertebrata, and for this reason we have determined to place them first. We give the name of mollusca, from the Latin mollis, soft, to animals which, in the general features of their organization, resemble snails, oysters, etc. They have no articulated skeleton, nor vertebral canal, like the vertebrate animals. Their body is soft, and their skin, which is often covered by a shell, is never hardened so as to form a kind of external skeleton composed of a series of rings, as is the case in insects and the crustacea. The nervous system, an apparatus of so much importance, the action of which regulates all the phenomena of animal life, and the functions of which must necessarily be in harmony with its mode of conformation, differs altogether in the mollusca in its general disposition from what we observe in the vertebrata. There exists a nervous center which to a certain extent may be compared to the brain in superior animals, but this ganglionic mass is not continuous with an organ analogous to the spinal marrow. The other central parts of the nervous system are found on the opposite side of the digestive tube, and hence this canal is always embraced by a sort of medullary collar, from which the different nerves of the body arise. In other respects, this apparatus varies more in its arrangement than in the number of parts composing it. In a great many of the least perfect mollusks, such as the solen and many other acephala, which inhabit bivalve shells, the nervous system is generally composed of but 2 pairs of ganglia, united by 2 long interganglionic cords, giving rise to different branches. The ganglia of the anterior pair are sometimes considerably separated from each other, and only united by an intermediate cord, and sometimes glued one to the other, or even confounded in a single mass. They are situate above the esophagus, and far from the posterior ganglia, which are placed beneath the intestine towards the posterior part of the body. In some mollusks the nervous system is still more simple in its composition, but in general the ganglia tend to approximate the esophagus more and more, and in most of these animals we find a greater number of small medullary masses, some of which form a sort of nervous center, and the others are distributed in different parts of the body. Thus, in the snails and most mollusks constructed on the same plan and named gastropods, from the Greek gaster, belly, and pous, foot, on account of their mode of crawling on the ventral surface of the body, there exists, above and in front of the esophagus, a medullary mass, which is the representative of the interior pair of ganglia above mentioned, and which is regarded by most anatomists as the brain of these animals. It furnishes nerves to the organs of the senses as well as to the neighboring parts, and is continued posteriorly by 2 interganglionic cords, which embrace the esophagus, and which, at a short distance, unite with a second nervous mass, situate beneath the digestive tube, and comparable to the posterior pair of ganglia, which we remarked when speaking of the acephalous mollusks, and 2 small nerves which arise from the brain unite to form a third ganglion, below the origin of the esophagus. In other gastropods, the aplysia or sea hares for example, to these ganglia is joined another, situated among the viscera, and united by 2 communicating threads to the medullary collar which surrounds the esophagus, and giving rise to the nerves of the intestines, liver, branchiae, ovaries, etc. We also find in these mollusks a 5th ganglion, which is very small, belonging to these latter organs, and in the pulpus and the cuttlefish, in which this system acquires its highest degree of development, the ganglionic parts grouped around the esophagus are larger and more complicated. For the cephalic and post-esophageal ganglia, united in a large esophageal collar, present laterally a 3rd pair of ganglionic swellings, which are lodged in a cartilaginous cranial cavity. From them arise the nerves of the feet. To recapitulate, we see that in this class of animals, the nervous system is essentially composed of a medullary collar, embracing the alimentary tube and formed by the communicating cords of the two pairs of ganglia, which are widely separated in the acephalous mollusks, but approximate more and more as we ascend in the series, formed by the gastropods and cephalopods. And the nerves which arise from each of these ganglia to be distributed to the different organs are at first simple, but very soon present in different parts of the body ganglionic swellings. But these ganglia, however numerous they may be, never form a regular longitudinal chain, extending along the middle line of the abdominal face of the body, as is the case in the articulated animals. As we have already said, in this great branch of the animal kingdom, there is neither an internal skeleton analogous to the solid frame of vertebrate animals, nor an external skeleton, similar to the tegumentary sheath, which envelops the whole body of articulate animals in a series of rings, and serves the same purposes as the skeleton, properly so called, of the superior animals. The general form of mollusks is extremely variable. Their body is always soft, and in a very small number of them only there exists internally some solid pieces, which are unarticulated and serve rather to protect the viscera than to furnish levers and points of support to the apparatus of locomotion. The muscles are attached directly to the integuments and act but very little beyond their point of insertion. Their motions are slow and in general ill-directed. In a small number of these beings, there are elongated and flexible appendages designed for locomotion, but in most instances the animal can change its place only by successively contracting different points of the inferior surface of its body, and, even when it possesses extremities, they are united in a group at one end of the body, and never arranged in a symmetrical series, as they are in vertebrate and in articulate animals. The skin of mollusks, always soft and viscid, often forms folds that more or less completely envelope the body, and this disposition has caused the name of mantle to be given to that portion of integument which ordinarily furnishes these expansions. Frequently this mantle or pallium is almost entirely free, and constitutes two large veils which conceal all the rest of the animal, or rather, these two laminae or membranes unite together so as to form a kind of tube, but at other times it consists only of a sort of dorsal disc, the edges of which alone are free, or surround the body more exactly under the form of a sac. In general, this soft skin is protected by a sort of stony cuirass named shell. It is a secretion having some analogy to that of the epidermis which produces this envelope. The follicles, ordinarily lodged in the edges of the mantle, deposit upon its surface a semicorneous matter, mixed with a greater or less proportion of carbonate of lime, which molds itself upon the subjacent parts and solidifies. The lamina or layer, thus formed, thickens and grows by successive deposits of new matter. Its superficies is not stony, but in form of a kind of epidermis. Sometimes it preserves a horny consistence throughout its whole thickness. In general, however, the proportion of carbonate of lime that it contains rapidly increases, and imparts to it a stony hardness. The internal surface is often harder than the rest, and possesses a particular structure which renders it vitreous or shining and nacreous. Sometimes the shell always remains enclosed in the thickness of the skin, but in general it is external, and extends beyond the mantle, so as to afford the animal perfect protection. Those which are unprovided with shells, or only have an internal shell, are called naked mollusks, and those in which the shell is visible are included under the name of conchifera, or sometimes testacea. The manner in which the shell grows is easy to understand. If we examine the shell of an oyster, for example, we observe that it consists of a multitude of superposed laminae, the separation of which may be effected by the assistance of heat. These laminae are formed successively by the mantle of the animal which they cover, and consequently the most external one must be the oldest, and it is also the smallest, and each new lamina that is added exceeds the lamina situate above, so that while the shell is augmenting in thickness, it is also increasing in size. In general, the distinctness of the lamina is less marked, and often the new matter is deposited in such a manner that its molecules exactly correspond to the molecules of the matter already consolidated, and thus gives to the whole a fibrous structure. Shells are adorned with most diversified and most agreeably arranged colors, which often vary with their age. They are almost always entirely superficial, and seem to depend on a sort of dyeing process performed by the skin of the animal, which is colored in a manner corresponding with that of its envelope. The coloring matter seems to be deposited upon the shell at the time of its formation, and its brightness is in proportion to the newness of the latter. It is produced by the edge of the mantle. When a shell happens to be broken, and the animal succeeds in repairing the accident, the part newly formed is always white, if it has not been in contact with the edge of the mantle, but if it correspond to this edge, it then assumes the color that the latter presents at the point touched. For example, when this edge is spotted, we find the corresponding spots on the margin of the shell, and, in proportion as the latter is elongated, these spots become confounded with those previously formed, and produce lines perpendicular to crossing striae, or they do not join the latter but remain isolated, according as the mantle remains unmoved, and preserves the same relation to the margins of the shell, or frequently changes its position according to the movements of the animal. Sometimes the secretion of the coloring matter varies with age, and accidental circumstances may also modify it. Light, for example, exerts a very remarkable influence on this phenomenon, for not only are shells that are most exposed to the action of this physical agent ordinarily most brightly colored, but when a mollusk lives fixed to a rock or in some spot hidden beneath a sponge or other opaque body, the part of the shell thus placed in darkness is always dull, and paler than that which is exposed to the contact of the solar rays. The duration of shells, and the length of time the animals live which inhabit them, are circumstances not yet determined. When exposed to the action of the air and the vicissitudes of temperature and moisture for some time, shells usually change their colors, and gradually become white. The animal matter which enters into its composition is destroyed, and disappears little by little. The laminae separate from each other, particularly under the alternate influence of heat and cold, and finally become reduced to a calcareous powder which is washed away by currents of water. All mollusks are provided with an alimentary canal, which is more or less folded on itself, and open at its two ends, either at the extreme points of the body, or at points more or less near to each other. There is always a voluminous liver, and we often find them furnished also with salivary glands and organs of mastication, but the intestines are never held in their place by the assistance of a mesentery. The blood of these animals is cold and colorless, or slightly bluish, and circulates in a very complicated vascular apparatus composed of arteries and veins. A heart formed of a ventricle and 1 or 2 auricles is found in the track of the arterial blood, and sends this liquid to all parts of the body, from which it returns to the organs of respiration. Sometimes we also find, at the base of the vessels which enter this latter apparatus, venous reservoirs, erroneously called pulmonary hearts, for, having nothing in their structure resembling muscle, they cannot set the blood in motion, and consequently do not merit this name. The organs of respiration vary so much that they cannot be well described at this place. We will merely mention that they are sometimes in the form of lungs, and at others in that of branchiae or gills. Nor can we say anything generally of the structure of the organs of the senses, which are, however, always less complete than in the vertebrate animals. Certain mollusks appear to be endowed only with the sense of touch and with the sense of taste, but in a great many we find eyes which vary in structure, and in some of these animals there even exists an apparatus of hearing, but none is known to possess a particular organ of smell. Mollusks are reproduced from eggs, but are sometimes hatched without and sometimes within the body of the mother, and then the young are born alive. In all cases they possess at birth nearly the form they preserve through life, and do not undergo metamorphosis. We have already stated that mollusks differ very much in the general form of their body, and as these external modifications are accompanied by corresponding differences in the degree of complication of their internal organization, they enable us to divide these animals into 6 natural groups. Cephalopoda, in the form of an open sac in front, from which the head appears, surrounded by tentacula. Pteropoda, membranous fins in the form of wings on the sides of the neck. Gastropoda, a fleshy foot occupying the ventral face of the body, and in form of a disc, or sometimes fins. Acephala, having 4 branchiae distinct from the mantle, and almost always a fleshy foot. Brachiopoda, provided with 2 ciliated arms which they have in place of them. Tunicata, unprovided with arms and special organs of motion. Cuvier and many other zoologists arrange the Sauropoda also in the branch of Mollusca, but it is now ascertained that these animals belong to the branch of Articulata, the 3rd great division of the animal kingdom. End of Lesson 1. Recording by Lauren Huff. Lesson 2 of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lauren Huff. Elements of Conchology by William Ruschenberger. Lesson 2. Class of Cephalopoda. General form, respiration, circulation, organs of digestion, cephalic cartilage, organs of locomotion, organs of the senses, nervous system, habits, division into 2 families. Family of Cephalopoda dibranchiata, Octopus vulgaris or pulp, argonaut, calmaries, cuttlefishes. Family of Cephalopoda tetrabranchiata, Nautilus, ammonites, belemnites, Foraminifera. Class of cephalopods. This class is composed of mollusks which are of fantastical shape, for their head is placed between the trunk and feet, or tentacula, which serve them for locomotion, and when they walk the body is uppermost and the head down, dragging on the ground. Their feet are attached around the mouth to the head, which circumstances obtained for them the name of cephalopods, from the Greek kephale, head, and pous, foot, pronounced cephalopod. The trunk of these animals is covered by the mantle, which is in the form of a sac, sometimes almost spherical, and sometimes more or less elongated. It encloses all the viscera and is open only in front. The head issues from this opening. It is round and generally provided with two round eyes, very analogous in their structure to those of vertebrate animals. The mouth occupies the center. It is armed with two jaws, and around this opening is found a crown of flexible and fleshy appendages, which are termed, indifferently, legs or arms, because they seem to be entitled to either appellation, for they serve both as organs of prehension and locomotion. The cephalopods are essentially aquatic animals, and consequently they breathe by means of branchiae. These organs are always perfectly symmetrical, and are found concealed beneath the mantle in a particular cavity, the parietes of which alternately contract and dilate, and the interior communicates externally by two openings, one in the form of a slit, serving for the entrance of the water, and the other prolonged in the shape of a tube or funnel, serving for the escape of water and excrement. Each branchia, which is in form of an elongated pyramid, the summit of which is directed forward, is composed of a great number of membranous lamellae or leaves, placed transversely and fixed on each side of a middle stalk. Each one of these leaves is divided into lamellae, which are in turn again subdivided, and it is in their substance that we find the capillary vessels where the venous is changed into arterial blood. The number of branchiae varies, and this difference is characteristic of the two great natural divisions of which this class is composed. In some there is but a single pair, while in others two pairs of branchiae are found. For this reason the first have been called cephalopoda dibranchiata, from the Greek dis, two, and bragchos, branchia or gills, two-gilled, and the last cephalopoda tetrabranchiata, from the Greek tetras, four, and bragchos, branchia, four-gilled. The heart is situated between the branchiae on the middle line of the body, and consists only of a single ventricle. The blood reaches it from the branchiae by the branchial veins, the openings of which are furnished with valves, and then penetrates the arteries which arise from this organ. The latter vessels are 2 or 3 in number, but one of them is always much larger than the rest, and one of them also has at its base a swelling or bulb, which is more or less muscular, and analogous to that found at the origin of the aorta in batrachians. The great artery to which we generally give the name of aorta is carried forward and distributes its branches to a part of the viscera, the head and legs. The other arteries go to the viscera, and the blood, after having in this way passed through all the organs, returns by the veins, and is emptied by them into a great vena cava, situate near the heart. The branchial arteries arise from the inferior extremity of this last vessel, and in the dibranchial cephalopods present a very remarkable arrangement. Before penetrating the branchiae, each one of them dilates so as to form a great venous sinus, which most authors regard as a branchial heart, but its parietes do not appear to be really muscular. We see, therefore, that the circulation is here carried on in a manner opposite to that of fishes, for the heart is found in the track followed by the arterial blood, while in fishes the venous blood passes through this organ, but in other respects there is a great resemblance in the general disposition of the circulatory apparatus of these two classes of animals, for in both the blood passes but once through the heart, and the whole of it traverses the respiratory apparatus before returning to the different organs. On the vena cava and its principal branches we remark a multitude of very singular spongy bodies, which when squeezed yield a mucosity, and which are attached to the parietes of these vessels. These appendages are enclosed in 2 membranous pouches, which perform the functions of a pericardium, and at the same time communicate by particular openings within the branchial cavity. In this way the water from without laves them in their interior, which is hollow, communicates by other holes within the interior of the veins, so that the blood must enter them. We know nothing certain in regard to their uses, but it is probable that they are the seat of some secretion, and that they serve as a reservoir to contain the superabundant blood of the veins, when the circulation is interrupted in the vessels, much in the same manner as the spleen seems to do in the superior animals. The apparatus of digestion is very complicated. The mouth is surrounded by a circular lip and armed with 2 vertical mandibles, which closely resemble the beak of a parrot. They are set in motion by powerful muscles. A fleshy tongue, furnished with papillae and many horny pieces, occupies the interior of this cavity, and is attached to a particular cartilage. Salivary glands, the number and arrangement of which vary a little, surround the pharynx and esophagus, and pour into the alimentary canal the product of their secretion. The esophagus contracts in general, and before terminating in the stomach, presents a large dilatation or crop, but sometimes this first digestive pouch is wanting. Commonly the stomach is in the form of an elongated sac, its parietes are muscular, and its structure reminds us of the gizzard of birds. A third cavity succeeds this organ, which in dibranchial cephalopods is in the form of a cecum spirally folded, while in the tetrabranchial it assumes that of a spherical sac internally lamellated. The bile is poured into this cavity by two canals. The liver is very voluminous, sometimes simple, and sometimes divided into two or more lobes. Its color is reddish yellow, and the texture is very soft. The intestine, which arises very near the cardiac orifice, is simple and communicates at a short distance from the pylorus with a glandular pouch which seems to be analogous to the pancreas. And after making several curves, this tube empties into the branchial cavity at the base of the funnel through which the water escapes that has served the purposes of respiration. In dibranchial cephalopods, there exists in the neighborhood of the liver another very remarkable secretory organ, which produces in abundance a blackish liquid called ink. The excretory duct of this gland empties into the intestine near its extremity, and when the animal is in danger, pours out, through the funnel or tube, enough of this liquid to darken the water around and thus conceal itself from the sight of its enemies. The ink of one of these cephalopods, the cuttlefish, is employed in painting under the name of sepia, and many authors suppose that the Indian ink of the Chinese is an analogous substance, though it appears the material commonly used in the manufacture of Indian ink is nothing but very finely powdered charcoal. The tetrabranchial cephalopods do not possess anything similar. It has already been stated that mollusks have no solid articulated frame within their body, similar to the skeleton of vertebrate animals. In the cephalopods, however, we find traces of something analogous, for there exists in the head a cartilage which not only protects the brain, but enlarges the head in different directions to furnish points of insertion to the principal muscles of the animal. The disposition of the organs of locomotion and prehension, which are fixed around the mouth, varies in these animals. In the dibranchial cephalopods there is a crown of 8 or 10 large fleshy tentacula, the inferior surface of which is furnished with suckers, like cupping glasses, by aid of which they fix themselves very strongly to bodies that they embrace. In the tetrabranchial cephalopods, on the contrary, these appendages, though very numerous, are slender and unprovided with suckers. The organs of the senses are most perfect in the dibranchial cephalopods. In these mollusks there are 2 very large eyes of spheroidal form, lodged in the lateral parts of the head. These organs are composed of a transparent cornea let into the skin, and sometimes protected by a fold like an eyelid, a crystalline lens, a vitreous body, a retina, a choroid coat, a sclerotica, etc. Nearly the same as in vertebrate animals. In the tetrabranchial cephalopods, the eyes are borne on projecting peduncles and consist of a cavity only, the black interior of which contains a retina, and receives the luminous rays through a circular opening. No auditory apparatus has yet been discovered in the first of these 2 families. We find in the cephalic cartilage of the latter 2 small cavities, closed on all sides except at the point through which the nerve penetrates. They lodge a membranous vesicle, and are filled with a peculiar fluid, containing a small stone. This, as we see, is still a more simple arrangement than that of fishes, for the whole apparatus is reduced to a vestibule and a nerve only. The nervous system of the cephalopods is more complicated than that of other mollusks, and the different ganglia, grouped around the esophagus, have a greater tendency to become confounded in a single mass. The medullary collar, thus formed, is composed of 3 pairs of ganglia, namely, the cephalic ganglia, the tentacular ganglia, and the thoracic ganglia. The 2 first pairs are placed above the esophagus, and, by joining the first, form a double collar around this tube. Sometimes they are very distinct, but at others they are almost entirely confounded. The cephalic ganglia give rise laterally to 2 large nervous cords, which from their origin enlarge into ganglia, and then furnish the optic nerves. From this species of brain, nerves also arise, which go to the mouth, and sometimes form around this opening a new collar, furnished with 2 pairs of small ganglia. The tentacular ganglia afford origin to the nerves of the feet or tentacula, which, before ramifying on these organs, also present ganglionic swellings. Finally, the thoracic ganglia, sometimes very distinct from the preceding, and at others confounded with them, furnish many nerves, the most important of which are, first, the 2 nerves of the viscera, which in their course present a pair of ganglia and distribute the branches of the branchiae, the heart, stomach, etc. Second, the nerves of the mantle, which in the dibranchial cephalopods also terminate in ganglia, from which arise a great many filaments. In the tetrabranchial cephalopods, the esophageal collar is simply protected by the cephalic cartilage, but in the dibranchial cephalopods, in which the nervous system acquires its highest degree of development, this medullary mass is lodged in a special cavity, hollowed in the cartilage through which the esophagus passes. The cephalopods are never hermaphrodite, as are most others of the mollusca. The ovary is always simple and lodged at the bottom of a sac formed by the body of the animal. Sometimes there is but a single oviduct, at others we find two, which open at the base of the funnel. Finally, all these animals are oviparous. All these mollusks are marine. They are very voracious, and feed chiefly on crustacea and fishes, which they seize by the aid of their supple and vigorous arms, and easily devour by means of their sharp mandibles. Their flesh is eaten. This class is divided into two families. The family of Cephalopoda dibranchiata, or acetabulifera, that is, cupping glass bearers, is very numerous. In it are placed the poulps, cuttlefishes, calmaries, argonauts, etc. Most of these mollusks have no external shell, and their naked skin includes a great number of contractile vesicles, filled with differently colored fluids, which, by alternately contracting and expanding, produce and cause again to disappear, in turn, often very brilliant spots. But we find in their interior a more or less developed shell, situated on the back. This shell is largest in the cuttlefishes. It is oval, and composed for the most part of a great number of transverse calcareous laminae. It is very common on the seashore, and is generally known under the name of cuttlefish bone. In the calmaries it is of a horny consistence, and in its form resembles a feather or lamella, and in the poulps it is merely represented by two horny stylets, lodged in the thickness of the mantle. The tentacula of these cephalopods form a single crown around the mouth, and bear on their internal face circular cups or suckers, the number of which varies from 8 to 10. In the following family we shall find an entirely different arrangement. The poulps, octopus, are easily recognized by their naked body, which is in the form of an oval sac, unprovided with fins, and their 8 very large and nearly equal feet. They make use of these last organs to seize their prey as well as to swim and crawl upon the ground, and are even formidable to swimmers on account of the force with which they press those bodies they embrace. These animals are essentially carnivorous. Their size is often very great. There is one species in the Pacific Ocean which attains about 6 feet in length. These mollusks are objects of terror to the natives of the Polynesian islands, who dive to the bottom of the sea for shells, but their size and strength are wonderfully exaggerated. Pliny speaks of a poulp that had arms 30 feet long, and a modern author gravely relates the history of one of these gigantic mollusks, which, attacking a vessel, nearly upset it. The common poulp, Sepia octopodia, is about 2 feet long. It inhabits the coasts of Europe, and commonly keeps among rocks. It destroys a great many fishes and crustacea. The argonauts, Argonauta, are cephalopods very closely allied to the poulp, but the pair of feet which is nearest to the back is dilated at the extremity into a broad membrane, and the body is always lodged in a very delicate and extremely beautiful shell, vulgarly called the paper nautilus. It is not certainly known, however, whether this shell really belongs to the animal that inhabits it, or whether it is derived from some other mollusk. Be this as it may, the cephalopod does not adhere to it, but uses it as a boat to float on the surface of the water when the sea is calm. 6 of its tentacula are then folded beneath and act as oars, and it is pretended that the 2 others, the extremities of which are enlarged and raised up, are spread for sails, and represented in the figure, but we should not infer from their structure that these tentacula are adapted to such a purpose. The common species is found in the Mediterranean, the Indian Ocean, etc. It is known to the ancients under the name of nautilus and pompilius. The calmaries, Loligo, differ from the preceding in their elongated sac, and being provided with 2 terminal fins by the horny lamina, lodged in the back, which supplies the place of shell, and by their tentacula, which are 10 in number, and not of the same configuration throughout. 8 of these feet are of moderate size, and are armed with little cups their whole length, while the 2 others are very much elongated, and have cups only near their extremities. The calmarets, Loligopsis, are remarkable for the great length of 2 of their arms, which are filiform, and widened at the end only. In other respects they differ but little from the calmaries. They are found in the Mediterranean. Certain cephalopods which resemble the calmaries very much, but have their long arms furnished with hooks, form the genus of Onychoteuthis, from the Greek onyx, in the genitive onukos, nail, and teuthis, a calmari, that is, a calmari with nails. The cuttlefishes, Sepia, have the tentacular appendages arranged like the calmaries, but their body, which is oval and depressed, is furnished with fleshy lateral fins occupying the whole length of the sac, and the back is sustained by a large internal shell, the structure of which has already been mentioned. The species most commonly found in the seas of Europe, Sepia officinalis, attains a foot in length or more. The cuttlefish bone or shell is used as a dentifrice, and is employed in the arts for several purposes, as for polishing, for forming moulds for silver castings, and as a pounce. The family of Cephalopoda tetrabranchiata has for its type the nautilus, a very remarkable mollusk, the body of which is enclosed in the last chamber of a large shell, folded spirally, and divided by transverse partitions into several cavities. Each one of these partitions is pierced by a hole, and the canal thus formed, which is called the siphon, extends to the posterior extremity of the shell. It is traversed by a contractile membranous tube posterior to the body of the animal. This structure seems designed to facilitate the ascent or descent of the animal in the water by increasing or diminishing the specific gravity of the shell, for the siphon communicates with an external reservoir and can empty or distend itself with the water found in it. Now the chambers which it passes through are filled with air, and when this tube becomes inflated, it must compress this elastic fluid and increase its density, which at the same time augments the specific gravity of the whole shell, and must give it a tendency to sink towards the bottom of the water in which it floats. The conformation of the animal differs very much from that of the poulps, calmaries, and other dibranchial cephalopods. The head of the nautilus is surrounded by a large fleshy disc, which bears some analogy to the foot of the gastropods, and probably serves the animal in crawling. The tentacula, which are inserted near the mouth, are not furnished with cups as in the preceding family. They are retractile and in considerable number. The eyes are pedunculate, that is, supported on a sort of foot stalk or stem. There is no organ of hearing, nor pouch, nor fins, and the branchiae are 4 in number. A great number of shells are found in the fossil state, which are very analogous in structure to the nautilus, and which probably belong to cephalopods of a similar conformation. They are the ammonites, vulgarly called horns of Ammon, in consequence of the resemblance of their volutes or whorls to those of a ram's horn. These animals were among the most ancient inhabitants of the earth, and lived in every sea. Their remains abound in the secondary formations, and are met with in all parts of the world, but they have long since disappeared from the surface of the earth, and in those layers which rest upon the chalk not even a trace of them is found. Consequently, their destruction must have occurred at a period long anterior to the creation of nearly all the mammals. They vary much in form, and still more in size. Some are not larger than a bean, and others more than 4 feet in diameter. More than 300 species of them are known, and they are divided into several genera according to the manner in which the shell is rolled, the position of the siphon, the form of the partitions, etc. We give the name of belemnites, from the Greek belemnon, a dart, to other fossils which also seem to have belonged to the cephalopods, but which, in place of being an external shell, must have been lodged in the interior of the animal, like the bone of the cuttlefish. They are conical in form, and are chiefly composed of a series of little horns, fitting one in another like boxes in a nest, traversed by a siphon, and terminated anteriorly by a horny plate that forms a sort of chamber, in the interior of which we sometimes find the remains of an ink bag, similar to the sac which fulfils the same purposes in the naked cephalopods. The belemnites are not met with in strata as old as the ammonites, but they abound in the middle and upper layers of the secondary formation, and cease to exist in the upper layers of the chalk. Until lately, a host of microscopic shells of lenticular form and without apparent opening, designated by authors under the names of nummulites, from the Latin numma, a piece of money, camerines, from the Latin camera, chamber, foraminifera, from the Latin foramen, a hole, and fero, I bear, etc., were referred to the order of cephalopods. These little bodies abound to such an extent in certain soils, that they of themselves exclusively constitute chains of hills and immense banks of building stone. But they are also found in European seas, and on observing them when alive, we are convinced that the animals to which they belong do not resemble either the cephalopods or even the mollusks in anything. They are beings of a very peculiar structure, and seem more approximate to the polypi. End of Lesson 2. Recording by Lauren Huff. Lesson 3 of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lauren Huff. Elements of Conchology by William Ruschenberger. Lesson 3. Class of Gastropoda. General conformation. Classification. Order of Gastropoda pulmonea. Organization. Division into 2 families. Family of terrestrial pulmonea. Limax. Vaginulus. Helix. Bulimus, pupa, chondrus, clausilia, achatina. Family of aquatic pulmonea. Oncidium, planorbis, limnaeus, physa, auricula. Order of Gastropoda pectinobranchiata. Organization, classification. Family of Trochoides. Trochus, turbo, delphinula, turritella, cyclostoma, valvata, paludina, litorina, Monodon, Phasianella, Ampullaria, Janthina, Nerita. Class of Gastropoda. Mollusks that are provided with a head and crawl upon the belly, or swim by means of a fin formed of this part of the body, constitute a very numerous class, the type of which is the slug and snail. The body is elongated, and terminated anteriorly by a more or less developed head, which ordinarily has tentacula inserted above the mouth, and the back is furnished with a mantle, which extends more or less, and the belly is covered by a fleshy mass, generally in the form of a broad disc, and serves the animal for crawling on the ground, but which is sometimes very much compressed, and then constitutes a vertical fin. Many of these animals are entirely naked. Others have an internal shell concealed in the thickness of the mantle, but most of them have an external shell, and this calcareous envelope is almost always sufficiently large to contain them entirely, and afford them protection. The arrangement of these shells varies much. Sometimes they are composed of many pieces, at others of a single piece. Sometimes they are symmetrical, at others not symmetrical, and in this last case, in proportion as they are elongated, they are rolled or twisted upon themselves, and constitute a spirally twisted cone. This last form, which is seen in the shell of the snail, is the most common in gastropods, and presents numerous varieties. Sometimes the part which grows less rapidly and upon which the cone rolls itself is full, and sometimes empty. It is called columella or pillar, and when empty we give the name of umbilicus to this opening. If the turns of the shell remain in the same plane, the spire is flat or concave, and the general form of the shell is discoid, resembling a disc, as in the planorbis. Sometimes the height of each turn completely envelopes the preceding involutions, so that the spire is concealed, but in most cases the turns are inclined towards the edge of the columella, and there results an oblique spire, which is more acute in proportion as the cone is less rapidly widened. Those shells are called turbinated, in which the first turns are raised above the succeeding ones, forming a projecting spire, and it is remarked that the turns or whirls are almost always directed from the right side. Sometimes, however, the spire of these turbinated shells is turned from the left side of the animal, and in this case they are said to be perverse. The mass of the viscera occupies the upper part of the cone formed by these shells, and always remains enclosed in it, but the head and foot project externally when the animal extends itself to walk, and return again into the last turn of the spire when it contracts, and the size of this latter part of the shell and the form of its opening are always in relative proportion to the foot. In most of the aquatic gastropod mollusks with a spiral shell, there is a horny or calcareous disc or door, called operculum, which is fixed to the posterior part of the foot, and which closes the entrance of the shell when the animal retires into it. The operculum of certain small shells constitutes what is vulgarly termed an eye stone. The organs of respiration are formed sometimes for breathing the air, and sometimes for aquatic respiration, but in mollusks with a spiral shell they are always lodged in the last turn of the spire, and receive the ambient element beneath its edge, either by a hole pierced through the mantle, or between the body and the free edge of this cutaneous fold, which is also often prolonged into a canal, by means of which the animal can obtain the fluid, whether air or water, necessary for its respiration, without putting its head or foot out of its shell. In this latter case, the shell has on its edge a notch or canal, destined to lodge the respiratory tube. This notch is near the termination of the columella, and on the side opposite to that towards which the spire is directed. Consequently this canal is to the left in the common species, and to the right in perverse shells. The heart is always aortic. It is generally composed of an auricle and a ventricle, and its position, as is the case with the respiratory tube, is in relation to the direction of the spire of the shell. This organ is situate on the same side with the tube, that is, on the side opposite to that towards which the shell turns, and the procreative organs, the form of which varies much, are always placed on this latter side, and consequently on the side opposite to the heart. The mouth is surrounded by contractile lips, and sometimes armed with horny teeth, which occupy the palate. In many other animals of this class, the anterior part of the esophagus is very fleshy, and possesses the faculty of projecting itself externally, in such a manner as to constitute a trunk. Sometimes the stomach is also furnished with cartilaginous or bony pieces, proper for dividing food. The intestine is folded on itself, and lodged between the lobes of the liver and ovary, and the anus is almost always situate on the right side of the body. In this class, the organs of the senses are less developed than in the cephalopods. The tentacles, which most gastropods bear on their front, varying in number from 2 to 6, serve chiefly for tact and perhaps for smell. No organ of hearing has been found, and their eyes, which are sometimes wanting, are very small and of a very simple structure. They resemble those of the nautilus, and are sometimes adherent to the head, and sometimes borne at the base on the side, or at the end of the tentacula. The class of gastropods is divided into 8 orders, the principal characteristics of which are derived from the disposition of the branchial apparatus. Order of Gastropoda Pulmonea. Gastropods formed for aerial respiration have no branchiae, but have a cavity on the back, upon the parietes of which the pulmonary vessels form a complicated network, and the lung receives the external air through a hole in the edge of the mantle, above the right side of the nape, which is susceptible of being opened or shut at the will of the animal. All the pulmonic gastropods are not, however, terrestrial mollusks. Many of them live in the water, but then they are obliged to come to the surface from time to time, to obtain air necessary for their respiration. All these animals feed on vegetable substances. The order of pulmonic gastropods is divided into two families, the terrestrial Pulmonea and the aquatic Pulmonea. The family of Pulmonea terrestria are generally recognized with ease by their 4 tentacles. These appendages are retractile, and those forming the upper pair, which are longest, have the eyes at their extremities. The mouth is armed with 1 palatine tooth, and a small tongue studded with microscopic teeth, and the body varies in form. Some are naked or only provided with an internal shell, while others have an external shell spirally twisted, with a blunt summit, and the mouth without a notch. The small tribe formed by the first is divided into Limax, Vaginula, etc. The tribe of terrestrial Pulmonea with an external shell comprises the genera of Helix, Vitrina, Bulimus, Pupa, Chondrus, Succinia, Clausilia, and Achatina. The Limaces, slugs, form the type of the terrestrial Pulmonea without apparent shell. The body, as everyone knows, is elongated, and their mantle is a fleshy disc, scarcely separated from the rest of the skin, and which only occupies the fore part of the back, where it covers the pulmonary cavity. It often encloses in its thickness a small, flat shell. On the right side of this species of shield there is a notch, at the bottom of which we observe a contractile opening that leads into the pulmonary cavity. The anus is situate upon the interior border of this respiratory orifice, and a third opening belonging to the procreative apparatus is situate on the external side of the base of the right superior tentacle. The 4 tentacula are cylindrical, more or less swelled at the end, and hollow. They are drawn in and pushed out, on unrolling themselves, like the inverted fingers of a glove, by the aid of muscular fibers lodged in their interior. The eyes, which are borne on the ends of the superior tentacles, are black. The mouth is armed with a sort of palatine tooth in the form of a crescent, and a smooth tongue. The heart is lodged in a particular cavity beneath the mantle, and is composed of an oval auricle which receives a large pulmonary vein, and a pear-shaped ventricle from which the aorta arises. And there exists near the heart a secretory apparatus which pours out a viscid matter upon the external surface through an excretory canal opening near the respiratory orifice. These animals are herbivorous. They feed principally upon young plants, fruits, mushrooms, and are most voracious toward evening. During the heat of the day they remain concealed in holes under stones, or some heap of half-decayed leaves, or even in the earth, and they seldom go out except in the morning and evening when the air is humid. They are especially abundant after rain. During the cold season they bury themselves in the ground and remain torpid. Some, called aerions, have the pulmonary orifice situate near the anterior part of the dorsal shield, such as the Limax rufus, which is everywhere met with in wet weather. A decoction of this species is sometimes used in France for pulmonary disorders. The others, named Limax properly so called, or Lima, have this orifice situate more posteriorly, and frequently have a pretty well formed internal shell. The Limax cinereus, which inhabits caves and shady forests, belongs to this division, as well as the Limax agrestis, which abounds in some countries and is very injurious to agriculture. We give the names of Vaginula, Testicella, and Parmacella to other naked gastropods, nearly resembling the Limaces, but which differ from them in the position of the anus, the extent of the mantle, etc. The snails, Helix, form the most important tribe of terrestrial Pulmonea, with a complete and apparent shell. Their organization differs very little from that of the Limaces. The mantle, instead of being in the form of a convex shield, constitutes a large cone twisted on itself, containing the viscera, which is covered by the shell. We distinguish them by their shell, the opening of which is ordinarily raised like a pad or collar, forming a thickened lip in the adult. The shell is a little twisted by the projection of the penultimate whorl of the spire, and in this way takes somewhat of a crescent shape. In snails properly so called, this opening is at least as broad as high, and the shell is sometimes globular and sometimes depressed. The habits of these mollusks are nearly the same as those of the Limaces. In the summer they are very voracious, but in the autumn they eat very little, and on the approach of winter they retire into some hole, draw themselves into their shell, shutting up the mouth with the calcareous matter secreted by the edge of the mantle, and remain torpid until spring. Very curious and frequently repeated experiments have proved that not only do wounds inflicted on these animals readily heal, but that considerable portions of the body, after being removed, can be renewed. The eyes, the tentacles, and even the head of snails have been known to be entirely renewed in this way. A very great number of species of snails are known; they are found in all parts of the world. We give the name of vitrina to snails of the shell which is very thin, flattened, and unprovided with a thickened lip, and too small to enclose the body entirely. Some small species are found in Europe. The bulimes, Bulimus, have an elongated shell, the opening higher than wide, furnished with a thickened lip, and without notches. A small species which is found in France is remarkable for the singular habit of successively breaking the whorls of the apex of the shell. There is a large species in Brazil which is eaten as a delicacy. Other mollusks of the same tribe, the genus Pupa, have an ellipsoid or even almost cylindrical shell, with the opening higher than wide, furnished with a thickened, notched, and generally dentate lip. They are of small size and live in humid places, among moss, etc. Shells of the genus Chondrus also have a notched and dentate lip, but their form is more ovoid. The genus of Clausilia is composed of small mollusks which live in moss, at the roots of trees, and have a shell similar to that of the pupa, but much more slender and pointed. The ambrettes, Succinia, differ from all the preceding in the absence of a thickened lip around the opening of the shell, which is oval, and too small to lodge the entire animal. The shell is thin and translucent, and obtains its name from a supposed resemblance to amber. They live upon plants that grow along the margins of rivulets and brooks. The genus of Achatina is composed of large snails, which, in warm countries, feed on shrubs. They have an oblong shell, with the opening wider than it is high, without a thickened lip, and truncate at the extremity of the columella, a disposition somewhat analogous to that of the shell of most marine gastropods. The family of Pulmonea aquatica have but 2 tentacles. Their mode of respiration obliges them to come frequently to the surface of the water to breathe. They cannot keep at great depths, and they ordinarily live in fresh waters or near coasts. As in the preceding family, we find here mollusks without a shell, and others that are provided with one. The first form the genus of Oncidium, which have a very straight and very extensible elongated body. They inhabit the fresh waters of the warm parts of both continents. The second are subdivided into the genera of Planorbis, Limnea, Auricula, etc. The mollusks of the genus Planorbis have a thin shell rolled upon the same plane, which is consequently discoid, and the whorls very gradually increase in size. Their tentacles are long and filiform, and the eyes are placed at the internal side of their base. These gastropods feed on vegetable substances, and inhabit stagnant waters. In winter they bury themselves in the mud and lie torpid. The Limnea have the same habits, and are almost always found in the same localities as the Planorbis, from which they are readily distinguished by the form of their shell, the spire of which is oblong. Their tentacles are thick and triangular. In the laying season they are often found in great numbers joined together, so as to form a sort of chaplet. They swim on the back, with the ventral disc extended on the surface of the water, and in the winter they become torpid like the Planorbis. We give the name of Physa to small mollusks found in fountains, the shell of which is similar to that of the Limnea, but is very thin, without a thick lip, and without a fold on the columella. The animal, when it crawls or swims, covers its shell with the 2 lobes of its mantle. In other respects it closely resembles the Limnea. The Auriculae differ from the preceding by having large oblique grooves upon the columella of their shell, which is oval or oblong. The name is derived from the shape of the opening, resembling a human ear. Many of these gastropods are of considerable size. One species is found on the shores of the Mediterranean. Order of Pectinobranchiata. This division of the class of gastropods is the most numerous in genera and species. It comprises nearly all the mollusca, in which the shell is univalve and spirally twisted, and many of those in which the shell is simply conical. The most remarkable feature of almost all these animals is the arrangement of the branchial apparatus, but this character is not constant, for in 2 genera, Cyclostoma and Helicina, which in other respects are too nearly allied to the ordinary Pectinobranchiata to be separated from them, there are no branchii, and their respiration, which is aerial as in Pulmonea, is carried on by means of a vascular network that lines the bottom of the respiratory cavity. This cavity occupies the last whorl of the shell, and opens externally by a great slit, situate betwixt the body and the edge of the mantle. In most instances it lodges branchii, which are composed of small leaves or fringes arranged parallel, and attached to its superior parietes upon 1, 2, or 3 lines, according to the genus. All these mollusks have 2 tentacles, and 2 eyes, sometimes borne on particular peduncles. The mouth is in the form of a tube or trunk, and encloses a tongue armed with small hooks. The males have, on the right side of the neck, an appendage, sometimes very thick, which cannot in general be drawn into the body of the animal, but is folded into the branchial cavity. the rectum, and the oviduct are also found on the right side of this cavity, and near them we remark a particular organ, enclosing a very viscid humour, designed to form a common envelope around the eggs. This order is divided into 3 families. In the 2 first, that of the Trochoides and of the Capuloides, there is no siphon by the aid of which the animal can breathe without leaving its shell, while in the 3rd family, that of the Buxonoides, there is a respiratory tube, formed by a prolongation of the edge of the pulmonary cavity on the left side, which passes through a corresponding canal or notch in the shell. The family of Trochoides are distinguished from other pectinobranch gastropods without a siphon by the form of their shell, which is spiral, with an entire aperture, and by the existence of an operculum, or some organ in the place of it. This family is divided into 3 tribes, which are distinguished by the form of the opening of the shell, namely, Trochus, in which this opening, angular at its external edge, is nearly quadrangular, and as regards to the axis of the shell lies in an oblique plane; the tribe Turbo, in which the mouth of the shell is perfectly round; and the tribe of Hemicyclostoma, in which this opening is more or less in the form of a crescent, as in the helices. The Trochus, so called from the general form of the shell, that of a top, its spire is more or less raised, and terminates in a point, and the circumference is trenchant or carinate. Animals of this tribe are mollusks with a short foot, the mantle ordinarily furnished on the edge of 2 or 3 pairs of filiform appendages, the 2 eyes being placed on a swelling at the base of the tentacles, the mouth armed with a sort of spirally rolled tongue, and the anus opens on the right side of the respiratory cavity, which encloses 2 unequal branchii. The operculum is horny, and marked by numerous spiral turns. The tribe of Trochus is divided into several little groups, according to the absence or presence of an umbilicus, and some other not very important characters. The Celarium is a trochus in which the shell is conical in form, with a quadrangular aperture and an extremely flaring umbilicus. The anterior edges of all the involutions or whorls of the spire are marked by a crenulated cord, that is, notched on the edge. Among the trochi, properly so called, with an umbilicated shell, we will mention the Trochus agglutinans, which is found in the West Indies and Pacific. It has the singular faculty of gluing to itself movable bodies found on the ground on which it rests. Sometimes it glues stones, and sometimes shells or pieces of shells, according to the place where it is found. From this habit of building out its habitation from materials not its own, it is sometimes called the mason. There are some without an umbilicus, very conical and very tall, that are marked by numerous whorls in the spire, with crossing striae. The extremity of the columella is much twisted, and projects beyond the origin of the lip. Another variety is remarkable for a deep excavation at the base of the columella, resembling an umbilicus, and a projection of the circumference. There are other species without an umbilicus, conical with a very oblique base, the aperture large, slightly angular, the columella twisted, and forming a kind of tooth at its termination. Such is the rainbow trochus, the nacre of which is a beautiful golden green, with very brilliant reflections of red. The tribe of Turbo comprises all the pectinobranch gastropods which have a completely and regularly turbinated shell, terminated by an entirely round aperture. In it we range the Turbo properly so called, Delphinula, Turritella, Scalaria, Cyclostoma, Valvata, etc. The turbos, properly so called, are recognized by their round or oval thick shell, in which the aperture is completed within by the whorl of the spire next to the last. These mollusks have 2 long tentacles, which at their base externally support the pedunculated eyes. On the sides of the foot we remark the membranous wings, sometimes simple, sometimes fringed or furnished with 1 or 2 filaments, and their operculum is sometimes horny, at others calcareous or extremely thick. Among the varieties of this genus is the Turbopica, which inhabits the equatorial regions of the Atlantic Ocean. It is a common, heavy shell. It has a horny operculum, and is remarkable for a tooth situate at the orifice of the umbilicus. The Delphinula has a thick shell like the last, but rolled almost in the same plane, and the aperture is entirely formed by the last whorl of the spire. The most common species is remarkable for its twisted and branching spines. The Turritella and Scalaria have a very elongated spire. In the first, the mouth or aperture of the shell is formed as in the Turbo, properly so called, and in the last it is similar to that of the Delphinula. The Wenteltrap, or precious Scalaria, has the volutions connected by longitudinal ribs. The Cyclostomi, which are distinguished by the absence of branchii, and by their arterial respiration, also have a shell with a round mouth, closed by a thin circular operculum. It is in form of an oval spire, and finely striated transversely. These animals live in woods, under moss and stones. Finally, the freshwater mollusks, named Valvata, in which the shell somewhat resembles that of the planorbis, but has a circular aperture, furnished with an operculum, also take their place here. One species, which inhabits stagnant waters in France, has been called the feather bearer, from the manner in which the branchia, which is in the form of a feather, is protruded and floats on the surface of the water when the animal wishes to breathe. The tribe of Hemicyclostoma is composed of pectinobranch gastropods, which resemble snails in the form of their shell, of which the whorl next to the last presents a sunken arch, which gives its aperture more or less resemblance to a crescent. They form many genera, among which we will mention the Paludina, Litorina, Paludina, Monodonta, Janthina, and Nerita. The Paludini were for a long time confounded with the Cyclostomi, but the aperture of their shell is without the rolled lip, and they are provided with branchiae for breathing in the water. They show the first vestiges of the siphon which always exists in the following family. We observe on each side of the body a sort of membranous wing, and on the right side of this prolongation curves into a small canal, through which water is introduced into the branchial cavity. Many species are found in fresh waters in the United States. A common species, the Paludina vivipara, so called because its young are born alive, is marked by purplish longitudinal bands, and the shell is greenish. It abounds in the standing waters of France. The Litorini do not differ much from the Paludini, except that they have a thicker shell and inhabit the sea. The Vinot, or Turbo litorius, the shell of which is round, of a brown colour, streaked with black, belongs to this genus. It abounds on the coast of France, where it is eaten by the natives. The monodons are distinguished from the Litorini by the presence of a blunt, slightly projecting tooth at the base of the columella. The animal generally bears on each side 3 or 4 filaments as long as the tentacles, and has the eyes supported on peculiar pedicles. A small species, the Trochus tessellatus, with a brown shell, spotted whitish, abounds on the coasts of France. The Phasianella have an oblong or pointed shell. The aperture is higher than it is wide, and furnished with a strong operculum. The base of the columella is flattened, but there is no umbilicus. These animals inhabit the Indian Ocean, and their shells are much sought after by collectors on account of the beauty of their colors. The shell of the Ampullaria is round, ventricose, with a short spire, as in most of the helices. The aperture is higher than it is wide, and provided with an operculum. The columella is umbilicated. The Ampullarii inhabit the fresh or brackish waters of hot countries. Many species are found in the United States. The shell of the Melania has the aperture higher than wide, and it enlarges the opposite to the spire. The columella has neither plicae, folds, nor umbilicus. The length of the spire is very various. The animal has long tentacles, the eyes being about 1/3 of their length, on the external side. The Melanii inhabit freshwater rivers. A number of species is met with in the United States. The Janthini resemble snails in the general form of their shell, but differ considerably from the different mollusks we have described in the form of the animal. It has no operculum, but carries on its foot a substantial vesicular organ, which resembles froth bubbles, which hinders it from crawling, but enables it to float on the surface of the water. Its head is in the form of a trunk, and has a forked tentacle on each side. The common species, Janthina fragilis, with a very thin violet-colored shell, is very common in the Mediterranean and the seas of all warm regions. Great numbers of them are frequently met with in perfectly calm weather floating on the surface of the ocean. When the animal is touched, it ejects a deep violet-colored liquor, which dyes the water all around it. The vesicular or froth-like buoy is about 3 times the size of the animal. It is in the form of a cone, projecting from one side. The Nereidi are distinguished by the columella being a straight line, which makes the aperture of the shell either semicircular or semi-elliptical. They are divided into Natica, in which the shell is umbilicate and the operculum horny, into Nerita, properly so called, in which the shell is not umbilicate, thick, and the operculum stony, and into Neritina, in which the shell is also without an umbilicus, very thin, and the operculum is horny. The last live in fresh waters. End of Lesson 3. Recording by Lauren Huff.
Lesson number 4 of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Elements of Conchology by William Ruschenberger. Lesson 4. Family of Buccinoids. Buccinum. Buccinum properly so called. Harpa. Purpura. Cassis. Cerithium. Murex. Strombus. Voluta. Ovula. Cypraea. Conus. Family of Pectinibranchiata, Capulloida, Piliopsis, Hipponyx, Crepidula, Calyptraea, Siphonaria, Sigaritus. Order of Gastropoda tubulibranchiata. Order of Gastropoda scutibranchiata. Haliotis, Fissurella, emarginella. Order of Gastropoda cyclobranchiata. Patella, chitin. Order of Gastropoda inferobranchiata. Order of Gastropoda tectibranchiata. Plurobranchus, Aplysia, Dolabella, Bullia, Bulla. Order of Gastropoda nudibranchiata. Eolidia, Glaucus. Order of Gastropoda heteropoda. Carinaria. Class of Mollusca theropoda. Cleoborealis. In the family of buccinoids, the shell is spiral, and in its aperture, near the extremity of the columella, there is a canal or notch, serving for the passage of the siphon or respiratory tube, which is formed by a fold of the mantle, and destined to afford the animal the power of breathing, without going out of its shell. The family is divided into 3 tribes, namely Buccinum, Murex, and Angiostoma. The tribe of Buccinum comprises all the buccinoids in which the shell is without a plica (fold) in its columella, but is furnished with a notch or short canal inflected towards the left, and its aperture is very large. The foot of these mollusks is generally of moderate length, and rounded in the front. The mantle is unprovided with fringe and is prolonged anteriorly into a long canal, which is always uncovered. The mouth is armed with a trunk, and there is generally a small horny operculum. The Buccinum properly so called has an oval elongated shell, the aperture of which is oval, notched, and without a canal. The operculum is complete, and these animals have no veil on the head like the Cerata. A great many species are known. Lamarck describes 58 species. We give the name of Nassa to mollusks that differ very little from the preceding, but in which the columella of the shell, in place of being convex and naked, is covered by a plate of greater or less thickness. Dolium also belongs to this tribe, and is remarked for the length of its trunk and the size of its foot. It is without operculum, and the shell is recognized by being almost globose, very ventricose, and furnished with projecting ribs, which follow the direction of the whorls of the spire, and make the margin of the aperture undulated. A very large species is found in the Mediterranean. The harps, Harpa, have a more oval shell, furnished with projecting ribs parallel with the margin of the aperture, and differ from the preceding in the form of their foot. The Purpura is furnished with an operculum, like the Buccinum properly so called, which it very much resembles. The shell is ovate, thick, most frequently tuberculated, and characterized by its flattened columella, which is trenchant towards the end opposite to the spire, and forming at that point with the external margin of the aperture an unprojecting canal. The helmet, Cassis, also very much resembles the ordinary Buccinum, but their shell, which is ovate with a short, slightly projecting spire, is furnished with a transversely wrinkled plate, covering the columella like the Nassa. The aperture, sometimes oblong, sometimes straight, is also wrinkled externally, and its notch terminates in a little short canal which is curved backwards. The Terebra differs still less from the Buccinum properly so called. It is distinguished from it only by the elongation of its spire. The Cerithium, the shell of which is turreted like that of the Terebra, but furnished with a short canal curved to the left or backwards, also differs from other Buccina by having a veil about the head. This animal has but a single branchia. Some of the mollusks of this genus inhabit the sea and others fresh water. A great many living species are known, but they were formerly more abundant than in our day. For in certain formations, such as the calcareous tertiary of the environs of Paris, an immense number is found in the fossil state. In the tribe of Murex, the aperture of the shell is always prolonged into a canal, either straight or inflected. The animals themselves very closely resemble those of the tribe of Buccinum. They have a trunk, no veil on the head, the right edge of the mantle furnishes with the lobes or filaments, and a horny operculum. They are all carnivorous and inhabit the sea. They are subdivided according to the form of the shell into Murex properly so called, Physis, Strambus, etc. The murices, properly so called, are distinguished by their shell, the canal of which is projecting and straight, and the walls are furnished with transverse elevations in form of varices or ridges, which often present spines or ramified in slashed plates or lamellae. The physis has a canal formed like the common murex, but the shell is without varices, that is, longitudinal ribs. The strombus has a shell in which the canal is straight or curved to the right, and its external edge expands with age, and this canal presents a sinus, hollow behind, in which the head lodges when the animal extends itself. The strombus, properly so called, the sort of wing formed by this prolongation of the margin of the shell is entire, while in the pterocera it is divided in the adult into long and slender digitations. All have the aperture of the shell very narrow, a disposition approaching to the characteristic of the following tribe. In the tribe of Angiostoma, the aperture is generally so narrow that, to enter it, the foot of the animal is obliged to be doubled. In some designated under the common name of voluta, the aperture, which is of various forms, is terminated by a notch without a canal, and the columella is marked by oblique, projecting plicae, folds. They are subdivided into volutus proper, in which the aperture is wide, and the columella is marked by some large plicae, and the last whorl of the spire is sometimes ventricose, sometimes conical. In the mitra the spire is in general pointed and elongated, and in oliva, so called, from the oblong or ellipsoid form of the shell, the aperture is long, narrow, and notched opposite to the spire, and the columella is marked by numerous plicae. In others, the shell is oval, the spire is concealed, and the aperture, which is long and narrow, has no plicae on the side of the columella, but presents a notch or canal at its two extremities. These are the ovulae. In others again, the Cypraea, porcellana, the shell, which is protuberant in the middle and almost as much contracted at the two extremities, has a very narrow aperture, transversely linked on both sides. When the animal expands itself, the mantle extends over the shell and envelopes it entirely, which in the progress of time produces considerable modification in the colours of the latter. For a certain period it deposits new layers of calcareous matter, not only around the aperture but also upon the whole external surface of this solid envelope. Also to this tribe of mollusks belongs the genus Conus, which differs from all the preceding in the conical form of the shell, which gives the genus its name. A slightly, or not at all projecting spire, forms the base of this cone, and the aperture, which is nearly straight, extends from one end of the shell to the other. A great number of shells, the principal characters of which we have briefly noted, are remarkable for the elegance of their form and the beauty of their colours. The cones, the porcelain shell, Cypraea, the volutes, and the olives especially are much admired for the brilliance of their markings. Many other mollusks of the family of buccinoids are also worthy of attention on account of the viscid liquid secreted by the gland placed, as we have already seen in the snails, betwixt the heart and rectum. And in a considerable number of these animals this humour has the property of changing colour when exposed to the action of air and light, and thus passes from greenish yellow to purple. Spread upon stuffs, it imparts to them this rich shade, and appears to be the material employed by the ancients for producing their beautiful purple dyes. Pliny relates that on the shores of Tyre and many other points along the coast of the Mediterranean there are found two genera of shells called Buccinum and Purpura, both of which furnish dye for the colours termed purple and conchylon. The first of these mollusks appears to be the Buccinum lapillus, and the second the Murex brandaris. But the quantity of colouring matter these animals yield is so small, it is difficult to explain how they could furnish so active a trade, and it must have been that the ancients used for the same purposes the purple liquid secreted by larger and more common mollusks, such as the Aplysiae, which we have yet to mention. The family of Pectinibranchiapuloids is recognized by the shell being widely open, slightly turbinated, and without either notch, siphon, or operculum. The conformation of the animal differs but little from that of the other mollusks of the same order. There is only a single branchia, often with very long filaments, attached transversely to the arc of the respiratory cavity. In this division are arranged the genera of Pileopsis, Hipponyx, Crepidula, Calyptraea, Sigaratus, etc. Animals of the genus Pileopsis or Capillus have their branchiae on the anterior edge of the respiratory cavity. The shell is conical and presents at its summit the commencement of a spire. Their neck is covered by a membranous plated veil, and they have two conical tentacles, and a tolerably long trunk or proboscis. They inhabit the seashores of warm countries. The genus of Hipponyx consists of fossil shells, which closely resemble the preceding, but are very remarkable for a support formed by calcareous layers upon which they rest, and which seem to have been secreted by the foot of the animal. The Crepidulae have an oval shell, the whole base of which is half closed by a horizontal plate, which supports the abdominal sac above it and is covered beneath by the foot. The Calyptroiae have in the interior of the shell, in form of a hollow cone, a small plate projecting downwards, which seems to be the commencement of a columella, and is embraced in a fold of the abdominal sac. Their branchiae are composed of long slender filaments like hairs. In some of them the plate or lamina adheres to the bottom of the cone, being itself bent into a portion of a cone or of a tube, and descending vertically. The siphonaria deserve notice because they show how much the organization of mollusks may vary without any very striking difference in the form of their shell. Until recently these animals have been ranged with the Patellae, to be described in the sequel, which they resemble in their shell, but differ from them very much in the structure of their most important organs. Their branchia is composed of a few leaflets transversely attached to the bottom of a respiratory cavity, which is on the back, and communicating externally by a lateral hole in the mantle. They do not appear to possess tentacles, but have a narrow veil on the head. The genus Sigaratus has a flattened shell with a slight spire and a very large aperture, which is concealed in the mantle. Order of Gastropoda Tubulibranchiata. Tubulibranch gastropods are very analogous to the pectinibranch gastropods, but are distinguished from them by very important differences in the organization of some of their organs, and in the structure of their shells, which is fixed to submarine bodies, and is in the form of a more or less irregular tube, the commencement of which only is spiral. It is divided into the genera Vermetus, Megalus, and Silicaria. Order of Gastropoda Scutibranchiata. In the general form of their body and the position of their branchiae, the scutibranch resemble the pectinibranch gastropods, but they differ from the latter in their anatomical and physiological characters. Their shell is very open, slightly or not at all turbinated, and like a shield it covers the branchiae or even the whole body. A peculiarity of their internal organization approximates them to acephalous mollusks. Their heart is traversed by the rectum and receives the blood by two auricles. They are not numerous and are divided into haliotis, fissurella, etc. The haliotides have a slightly turbinated shell with a spire so small that it is only seen from the inside. It is flattened and the aperture is very large. In the haliotides properly so called, there is along the columella a series of holes, through which the water reaches a slit on the right side of the mantle and penetrates to the branchial cavity. The filiform appendages of the edge of the mantle can be protruded through these holes, and all around the foot there is a double membrane cut in fringes and furnished with long filaments. On the outside of the tentacles we find two cylindrical pedicles bearing the eyes, and the mouth is armed with a trunk or proboscis. The external surface of the shells of these mollusks are not remarkable, but internally they are covered by a layer of nacre, the richest and most beautifully iridescent colors. They are found in great numbers on the rocky shores of California. The Fissurella are recognized by their conical shell placed upon the middle of the back and pierced at its summit by a small opening, which serves to give passage to the air necessary for respiration and also for the expulsion of excrements. We give the name of Emarginella to mollusks very much like the Fissurella, but their shell, in place of being open at the top, presents a slit or notch in the front, communicating with the branchial cavity. Order of Gastropoda Cyclobranchiata. The cyclobranch gastropods closely approximate the preceding, either in their general form or in the disposition of their internal organs, but they are distinguished by their branchiae being fixed around the edges of the mantle. Some, the Patellae for example, are provided with a broad-based conical shell which covers the whole body. They very much resemble the Fissurella and Emarginella. but the shell is not perforated at the apex, nor is there a notch in the front as in the latter. The head is furnished with two pointed tentacles having the eyes at their base and a stout trunk. The anus is situate to the right and a little above the head, and the branchiae are composed of leaflets or fringes arranged in a row around the body under the edges of the mantle. Petallae are found in almost all parts of the world. They are found on rocks to which they adhere and lie completely concealed beneath their shell, even after they are left by the ebbing sea. The other cyclobranch gastropods, called chitin, differ from all mollusks in the nature of their shell, which, instead of a turbinated or shield-like piece, is composed of a row of testaceous and symmetrical scales, generally 8 in number, let into the mantle and occupying the middle line of the back. The edges of this mantle, thus protected, are also very leathery, and often furnished with little scales, spines, or hairs. A membranous veil placed over the mouth takes the place of tentacles. The branchiae are composed of lamellar pyramids arranged on each side beneath the edge of the mantle. The anus is at the posterior extremity of the body. Chitins most abound on the shores of tropical seas. Order of Gastropoda, Inferobranchiata. The order of Inferobranch gastropods is composed of a very small number of naked mollusks, characterized by their branchiae consisting of a long series of leaflets placed on each side of the body, between the foot and the advanced edge of the mantle. Like the preceding, they are marine, and differ from them not only in the absence of every vestige of a shell, but also in some points of their internal anatomy, which approximate them to gastropods. They are divided into Phyllidea, from the Greek phullon, a leaf, in which the anus is posterior to the mantle and the head is furnished with 4 tentacles, and into the Phylidea, from Greek dis, 2, and phullon, leaf, in which the anus is on the right side and the head has a pointed tentacle and small tubercle on each side. In all of them the body is oval or more or less tuberculous. Order of Gastropoda Tectibranchiata. The tectibranch gastropods are like the preceding marine mollusks, but their branchiae are not symmetrical. They are composed of leaflets more or less divided, attached along the right side or on the back, and more or less covered by the mantle, which almost always encloses a small shell in its thickness. Their form is very variable. They are divided into Plurobranchus, Plurobranchides, Aplysia, Dolabella, Acera, etc. The Plurobranchi are mollusks of an oval form, in which the branchiae are fixed on the right side between the mantle and foot. The mouth is in the form of a proboscis or trunk and is surmounted by a small triangular veil and 2 tentacles. They have 4 stomachs, the second one of which is sometimes armed with bony pieces, and the anus opens behind the branchiae. One species, of a lemon yellow color, is found in the coast of France. The Aplysiae, which the ancients called sea hares, have a very singular form. The body resembles that of a sort of limax, but the edges of the foot, erected in flexible crests, surround the back and may be even reflected over it. Their head is supported by a neck of greater or less length, and furnished with 4 tentacles, the 2 upper ones being hollow like the ears of a quadruped, and placed about the eyes. The branchiae, in the form of very complicated leaflets, are fixed upon the back by means of a broad membranous pedicle, and covered by a small mantle, in the thickness of which we find a small horny shell, and the anus is situate behind the branchiae. These mollusks live on fucus and are provided with an enormous crop and 3 other stomachs, the second and third of which are armed internally with sharp hooks and cartilaginous plates. A particular gland secretes an acrid liquor, and pours it out through an opening situate on the right side. A purple-coloured liquid exudes sweats from the edge of the mantle when the animal contracts, and is sufficient in quantity to dye the water to a considerable distance around it. Several species of Aplysiae, which vary in colour, are found on the coast of France. The Dolobellae do not differ much from the Aplysiae except in the position of their branchiae, and their mantle at the posterior extremity of the body. They are found in the Mediterranean as well as in the Indian seas. The Acerae also resemble the Aplysiae in the complication and armature of the stomach, as well as in the position of their branchiae, and several other important points of their organization, but they are distinguished by their tentacles, which are short, very thick, and so arranged as to form together a large, fleshy shield about the eyes. Many of these animals effuse a purple liquid. Some are entirely unprovided with shell, or have only the vestige of a shell. These are called Acerae properly so called. Others have a shell somewhat rolled upon itself, and without a projecting spire or notch, which is concealed in the thickness of the mantle. These form the genus Bullaea. And there are still others in which the shell, only covered by a slight epidermis, is more convoluted and sufficiently large to afford a retreat for the animal. These constitute the division of Bulla. Order of Gastropoda Nudibranchiata. The mollusks composing this group are without a shell, and carry their branchiae on some part of the back. The structure of some of their internal organs approximates them to Pulmonea, the Inferobranchiata, and the Tectibranchiata. They all inhabit the sea. Among the genera possessing this kind of organization, we will cite the Doris, the general form of which is nearly the same as that of a Plurobranchus, and in which the branchiae are inserted in a circle around the anus, at the posterior part of the back. The Tritonea, in which the branchiae in form of miniature trees are attached along the two sides of the back, and in which the mouth is armed with lateral horny jaws similar to shears. The Glaucus, remarkable for its blue colour, in which the branchiae, 3 pairs in number, are situate in the same manner, but each one is composed of several long fringes, spread like a fan, and the Eulodiae, which resembles small limaces in form, in which the branchiae are composed of laminae, or leaflets, arranged like scales, more or less crowded together on each side of the back. They are found in every sea. Order of Gastropoda Heteropoda. These gastropods are not organized like all the preceding for crawling on the belly, but for swimming only. In fact, their foot, in place of forming a horizontal fleshy disc, is compressed into a vertical membranous plate, which is used as a fin. Their body is formed of a transparent gelatinous substance, and their branchiae are placed on the posterior part of the back. The principal genera of this group are the Carinaria and Pherola. The Carinariae have the abdomen, that is to say, a kind of sac enclosing the heart, the liver, and some other organs, covered by a symmetrical and conical shell, the apex of which is curved backwards, and the anterior edge covers the base of the branchiae. There is one species in the Mediterranean, but 3 have been discovered. The Pherolae have no shell, but in other respects very much resemble the Carinariae. Class of Mollusca Pteropoda. The mollusks composing this group are organized for swimming only. They possess no organ by means of which they can crawl, or even attach themselves to submarine bodies, but continually float in the sea, and move by the assistance of fins, placed like wings on each side of the mouth. They are all of the same size, and most of them inhabit the seas of warm countries, but they are also found in the neighbourhood of the poles. The Clio borealis, for example, abounds so extensively in the Arctic regions, that in spite of their very small size, scarcely an inch long, they become, in certain seasons, the ordinary food of whales. Their form varies much, some of them are naked, others are provided with a shell. They constitute several genera, the principal of which are the Clio, Hylia, Cleodora, Cymbulia, etc. End of Lesson 4. Lesson number 5 of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Elements of Conchology by William Ruschenberger. Lesson 5. Class of Mollusca, Acephala, or Lamellibranchiata. Organization, Classification. Family of Ostracea. Classification, Oysters. Gryphaea. Pecten, Lima, Malleus, Anomia, Spondylus, Perna, Etheria, Avicula, Pearls, Pearl Fishery, Pinna, Orca, Pectunculus, Trigonia, Family of Mytilacea, Mussels, Mytilus, Modiolus, Anodonta, Unio, Family of Camacea, Tridacna, Cama, Isocardia. Class of Mollusca Lamellibranchiata. All the mollusks we have heretofore considered have a distinct head. Those we have yet to mention are without this part, and their whole organization is of the simplest kind. The mouth is always concealed at the bottom of the mantle, or between its folds. They have neither teeth nor eyes. The nervous system is very simple, and the organs of locomotion are very incomplete or lamellibranch. In animals which form the class of acephalous mollusks, called by Lamarck Mollusca conchifera, The mantle is very large and folded in two, so as to enclose the body, as the leaves of a book are enclosed by its covers. Sometimes these two leaves are free at their inferior edge, sometimes united so as to constitute a tube. A shell, composed of two pieces called valves, covers this mantle entirely or in part, and at its superior part there is a hinge furnished with an elastic ligament, the play of which causes the valves to gape whenever the muscles, which extend from one valve to another, do not contract so as to keep them shut. The branchiae are in form of great leaves, transversely and regularly striated; they are always four in number, and placed between the internal face of the mantle, or pallial membrane, and the body of the animal. The mouth is at one of the extremities of the body, and has on each side of it two small triangular bodies, which are formed by the extremities of lips and serve as tentacula. The stomach, liver, and other viscera are lodged between the mouth and anus, and beneath the heart, which is situate on the back, and the lower part of the body is almost always prolonged into a fleshy mass, called the foot, which serves for motion, and sometimes has at its base a bundle of horny threads, called byssus, by means of which the animal fixes itself to submarine bodies. This class is divided into five great families, which may be recognized by the following characters. The family of Ostracea has the oyster for its type, and is composed of a great number of mollusks that are entirely without a foot, or having a very small one only, and which, for the most part, live attached to submarine bodies, either by their shell or by their byssus. The mantle is open behind as well as in front, and its two lobes are nowhere united to form particular openings, as we have remarked in all other Acephala. This group is divided into two tribes, according as there is a single muscle going from one valve to the other, or two of these organs, one placed near the anus, and the other in front of the mouth, an arrangement which exists in nearly all other Acephala. The first tribe, in which there is but one muscle, is called Monomyaria, and the second Dimyaria. To the first of these divisions belong the oysters, Ostrea. The shell of these mollusks is irregular, laminated, and composed of two unequal valves, united by a short ligament lodged at either extremity in a pit, and the hinge is without teeth or projecting laminae. The structure of the animal itself is very simple. Its mantle, the lobes of which are united above near the hinge, has a double fringed border. There is no appearance of foot. The adductor muscle of the valves, commonly called the heart, is situate near the centre of the body, and the heart, instead of being placed as usual on the back, is found between these muscle and the mass of the viscera, where it is readily distinguished by the brown colour of its auricle. The mouth is concealed under a sort of hood, formed by the union of the upper portion of the two lobes of the mantle. The tentacles which surround this opening closely resemble the branchiae, which are large and cover the whole abdomen, and the anus is seen above the muscle. All these mollusks have an ovary and produce eggs, which, at the time of laying, are extremely small and suspended in a whitish liquid, the appearance of which is analogous to that of minute drops of tallow. This spawn floats on the water, and soon adheres to neighbouring shells or some other submarine body, and the young oysters are always adherent, either to each other or to an adult oyster or to the rocks on which they live, but in the first case they generally detach themselves as they advance in age, and form extensive masses which are called beds or banks. Their growth is very rapid. We are assured that at the end of 3 months after being spawned they are of the size of $0.25, and at the end of the first year they are about 2 inches in diameter, and in 3 years they attain to about 3 inches in length. Nothing is precisely known of the duration of their existence. Many species of oysters are described. The most interesting and most extensively diffused is the Ostrea edulis, the edible oyster. It affords us a wholesome and agreeable article of diet, and its consumption has been immense since the remotest antiquity. These mollusks are ordinarily found in great numbers together, forming beds of considerable extent, situate near sea coasts, in bays or estuaries, or in localities where the sea is not very deep. They are objects of active pursuit, and are caught by means of a kind of rake with a net attached, called a drag, or dredge, which is drawn over the oyster bed, or where the water is shallow. They are taken up by long tongs of suitable formation. In France, after being caught, they are not immediately consumed, but are placed, planted out in particular basins, where they are kept for a time, and where they fatten and acquire a more delicate flavour. The largest are usually taken from the shell and pickled, but the others are eaten without preparation, and are esteemed by many only while alive. In fact, their preservation for any length of time is prevented by the habit these animals have of closing the shells as soon as they are taken out of the water. When dead, their shells remain open. European oysters possess a much more decided flavor, a stronger taste, than those of the United States. Americans, on first eating oysters in London or Paris, commonly complain of their strong, coppery taste, and it is not until after several trials they learn to prefer them to our own. The locality of oyster beds exercises a great influence over the taste of the oyster. Within the tropics they are rarely found good, and they are almost unknown in the Pacific Ocean. Oysters taken near the entrance of the Chesapeake and Delaware Bays have a high reputation, and are consumed in great quantities. Norfolk oysters are proverbially excellent. The markets of Paris and the north of France are chiefly supplied from the Bay of Cancale, from which the boats of Hull, near Cancale, and Granville carry away more than 80 millions of these mollusks every year, the major part of which are sent to Courseulles and other parts of Normandy, where they are considered establishments for the parkage, planting out, of oysters, whence they are sent post to Paris. About the beginning of the summer these mollusks cast their spawn. At this season it is customary not to eat them, and it is generally believed they are then unwholesome, but this opinion does not appear to be well founded. We give the name of Gryphea to shells, which for the most part are fossil, and which are very analogous to oysters, but the convex valve is more projecting at the apex or beak, and at that point bends into a hook. They are found in very ancient formations. There is but one living species known. The Scallops, Pecten, also called the pilgrim's shell, from being worn as an ornament by pilgrims, resemble the oysters in the disposition of the hinge, and may be easily recognised by their inequivalve semicircular shell, almost always marked by ribs, radiating from the apex of each valve towards their margin, and having on each side of the hinge an angular enlargement called the ear. In some species of Pecten there is the byssus, but most of these mollusks are not adherent, and can even swim with considerable rapidity by suddenly closing their valves. The mouth is furnished with many branched tentacula, which take the place of labial lamellae, and between the branchiae there is a small oval foot. St. James Pecten is found on the coast of France. The species of this genus are very numerous and are very generally diffused. The following genera are also placed among the oysters: Limand pedum, the shells of which are oval or oblong, and somewhat resembling the shell of the scallop in their general form. The hammer oysters, Malleus, which have a notch near the hinge for the passage of a byssus. The shell is irregular and the ears are prolonged, making its shape slightly resemble a hammer. The Anomie, in which the interior valve is deeply notched, alongside of the ligament, permitting the central part of the muscle to pass through it to be inserted into a plate, sometimes horny, sometimes stony, by aid of which the animal attaches itself. Spondylus, in which the shell is foliated or even spiny, and on each valve, at the hinge there are two teeth which are perceived into pits in the opposite valve. Perna, in which the hinge is composed of several ligaments inserted into particular pits, besides a great many other shells, either recent or fossil. Among the Ostracea provided into two distinct muscles, and the shells consequently marked, on the internal surface of each valve, by two irregular surfaces, muscular depressions, corresponding with the insertion of these organs, we will mention Etheria, Avicula, Pinna, Arca, and Trigonia. The Etheriae are very analogous to oysters. Their shell is large, inequivalve, very irregular, without teeth at the hinge, and provided with a ligament, which is partly internal and partly external. They are very rare shells, and have been overlooked by travellers from being attached to rocks at considerable depths. They inhabit the East Indian seas. The Aviculae are recognized by their inequivalve shell, with a rectilinear hinge furnished with a narrow ligament, and frequently elongated into wings at its two extremities. The body of these mollusks is very small and prolonged into a vermiform and conical foot, and furnished with a byssus, for the passage of which there is a notch in the side of the shell. The anterior adductor muscle is extremely small, and the labial appendages are very large. These mollusks have been divided, perhaps without sufficient reason, into two genera, Avicula and Meleagrina, according as the shell is with or without the wing-like prolongations, and the hinges armed with a tooth or unprovided with a similar protuberance. The shell of the latter is nearly equivalve, and the passage of the byssus produces in each valve a notch. The Meleagrinae are more scaly externally than the Aviculae. Their nacre is sometimes very thick and very brilliant, and the extravasation of the liquid destined for the periodical augmentation of the interior of the shell frequently gives rise to isolated deposits of this beautiful nacre forming pearls. The shell of the pearl oyster is nearly semicircular, scaly, and greenish brown externally. It grows to considerable size, and is to be found on the coast of Ceylon, in the Persian Gulf, the Gulf of Mexico, and in many other localities where it occurs in extensive beds attached by its byssus to submarine rocks. It is the object of an active fishery. Pearls, as stated above, are bodies of the same nature as the brilliant nacre lining the shell. They are composed of concentric layers of nacre very closely applied one over the other, like the coats of an onion, and are produced whenever this matter, instead of being spread out in thin layers over those already deposited, constitutes small isolated masses like little drops, or adhering to the shell by a mere pedicle. Their formation depends upon a kind of disease, or at least upon an anomalous activity of the secretory process which gives rise to nacre. Hence every circumstance that stimulates its secretion, such as the presence of a grain of sand or other foreign body betwixt the shell and the mantle of the animal, tends to bring about this formation. Pearl oysters are not only the mollusks that produce pearls. All shells that are internally nacreous may contain them. Patella, haliotides, and our common mussels sometimes contain them, and it is not uncommon to find them in a sort of large mussel, Unio, which inhabits the great rivers of northern Europe and the United States. But Meleagrinae furnish the greatest quantity, and yield the most beautiful pearls. The chief pearl fisheries are in the Gulf of Mannar on the coast of Ceylon, in the Persian Gulf, the Gulf of Panama, and on the coast of California. But there are banks of Meleagrinae pearl oysters in many other localities, such as the coasts of Japan, Cumana, etc. To obtain these precious mollusks, men accustomed to the exercise dive to the bottom of the sea and collect them at depths from 20 to 50 feet. To accelerate his descent the diver seizes a stone, weighing from 15 to 25 pounds with his toes, and on reaching the bottom he abandons the diving stone, which is drawn up by his attendants in the boat, to be prepared to take him down again, clings to the ground, and begins to fill a net which he carries down with him for the purpose. When, from the necessity of breathing or fear of sharks, he wishes to ascend, he checks the cord of the net, which is instantly felt by the attendants, who commence pulling up as fast as they are able. The diver remains with the net until it is so far clear of the bottom as to be in no danger of upsetting, and then commences hauling himself up by the cord, hand over hand, which his attendants are likewise pulling. When, by these measures, his body has acquired an impetus upwards, he forsakes the cord and rapidly ascends to the surface, swims to his diving stone, and by the time the contents of his net have been emptied into the boat, he is ready to go down again. One diver will take up in a day from 1 to 4,000 oysters. The diver seldom exceeds a minute under water. The more common time is from 53 to 57 seconds. In order that the banks may not be devastated, they are under regulation, and it is supposed that 7 years are required for the oysters to attain the full size. At Ceylon, the fishing season lasts from the middle of February to the end of March. During this period, the shores of Arapo are enlivened by crowds of people from all parts of the country. Divers, boat owners, speculators, and the curious assemble to behold pale, glistening pearls and rainbow-colored shells, while a lapidary attends, with his wooden stand and bow, to drill the pearls and fit them to be strung, so soon as they are got out of the oyster, which, according to all accounts, is a tedious and rather disgusting operation. The oysters are put into pens, and there left until the animal matter becomes softened by putrefaction, when it is subjected to frequent washings, and the pearls shine forth, emblems of purity in the loathsome mass. Some are of a bluish, some of a yellowish, and some of a whitish lustre. Each class finds a ready market among its admirers. In the East, the bluish and yellowish varieties are most prized, but in the eyes of the Christian fair the pure white shines the brightest. Ruschenberger's Voyage Round the World. The annual revenue from the pearl fishery of Ceylon is estimated at about $80,000. The pinnae have two equal valves in the form of a half-open fan, gaping and united by a ligament along one of their sides. A very large species is found in the Mediterranean, which lives half buried in the sand and anchored by its byssus, the filaments of which, being very strong, fine, and brilliant as silk, are employed by the inhabitants of some parts of Calabria and Sicily in the manufacture of precious stuff. The Archaea are distinguished from all their preceding by their equivalve shell. The hinge, which extends along the side of the valves, is studded with a great many little teeth, which fit into the intervals of those of the opposite side reciprocally. In some, the Arca, properly so called, the hinge is rectilinear, and the shell is longer in a direction parallel to this junction. In others, named Pectunculus, the hinge is curved, and the shell is lenticular in form. The first are met with near the shore in rocky situations, and are ordinarily covered by a hairy epidermis; the latter live in the mud. Finally, the Trigoniae, most of the species of which are fossil, are remarkable for their peculiar hinge; the right valve is furnished with two projecting plates, crenulate on each face, and entering between four plates of the left opposite valve, likewise crenulated upon their internal face only. There is but one living species known, Trigonia pectinata, which inhabits the seas of New Holland; externally it has the aspect of pecten without ears. In the family of Mytilacea, the mantle is widely open in the front, as in the Ostracea, but there is a particular opening for the escape of excrement; this orifice, however, is not prolonged into a tube, as in the families that follow, and there is no special aperture for the passage of water for the purpose of respiration. There is always a distinct foot, and the valves are approximated by the action of two adductor muscles. The Mytilaceae resemble each other sufficiently to be commonly known under the single name of mussels, but they require, nevertheless, to be separated into several genera, the most important of which are mussels properly so called, Mytilus, Anodonta, and Unio. Mussels properly so called, Mytilus, abound on the rocks of the coast of France. Mussels properly so called, Mytilus, abound on the rocks of the coast of France and of other countries, where they live fixed by their byssus, and generally closely united to each other. Their shell is shut, and its valves, triangular in form, are equal, arched, and united by a narrow ligament on the side of their acute angle. The mouth of the animal is situate near the summit of the shell, the opposite extremity of which gives passage to the byssus. The anus also is placed near the hinge, and opposite to this orifice there is a particular opening or small tube formed by the mantle, towards the round angle of the shell, where the water necessary for respiration passes. The edge of the mantle is fringed, and the foot is slender, cylindrical, and furnished behind with a silky byssus. Mussels are generally eaten as food, but they sometimes occasion a kind of poisoning, accompanied by very violent symptoms, occasionally followed by death. The Anodontae live in fresh waters, and are recognized by their thin shell, moderately inflated, oval, close, and without teeth in the hinge. They want the byssus, and are provided with a very large foot, compressed and almost quadrangular in form, by means of which they crawl on the sand or mud. A great many species are found in the great rivers of the United States. The Uniones closely resemble the Anodontae, but have a more complicated hinge, the right valve having a pit, fossette, into which a tooth of the left valve penetrates, presenting behind a long lamina, which, in its turn, is received between two laminae of the opposite side. These mollusks also inhabit fresh waters, but prefer those which are running. A very great number of species are found in our western waters, for the description of most of which we are indebted to the labours of Mr. I. Leigh, of Philadelphia. We also place in the same group certain marine mollusks, which resemble the Unios in their organization and the general disposition of the hinge, but in which the beaks (summits) of the shell are more arched, and from which projecting ribs radiate towards the circumference. Such are the genus Chardita, the form of which is more or less oblong or cardiform (heart shaped); the Cypricardia, in which the tooth beneath the summit of the shell is divided into two or three; the Corallophaga, in which the shell is thin and the lateral plate much effaced, etc. In the family of Chamasia, the mantle is closed and perforated by three openings only. Through the anterior one passes the foot, the next gives passage to the water necessary for respiration, and the third is for the expulsion of effete matters. As we have already stated, the last two openings are not prolonged into tubes, as in the next two families, and the hinge is very analogous to that of the Unios, for the left valve has a tooth near the summit, and, further back, a projecting plate, which are received into fossae (pits) in the opposite valve. This family is divided into Tridacna, Chama, Isocardia, etc. The Tridacnae have an equivalve shell, which is elongate and gaping in the front, or its edges are dentate. Their internal organization is remarkable in several particulars. The valves have only a single adductor muscle. The mantle is widely open in the front, to give passage to the byssus, and a little beneath the anterior angle presents another opening, by which water is conveyed to the branchiae. The third opening, which corresponds to the anus, is situate near the middle of the inferior border. To this genus belongs an enormous shell of the Indian Ocean, known under the vulgar name of the Holy Waterpot. It adheres to the rocks by its byssus, which is so large sometimes that an axe is required to cut it, and the shell itself occasionally weighs over 300 lbs. The Chama have an irregular equivalve shell, which is usually lamellar and rough. They live attached to rocks, corals, etc., like oysters, and they have a small foot bent, like that of man. The Isocardiae, on the contrary, have a free, regular convex shell with spirally curved summits, divided anteriorly. A large, smooth, red species, the Chamacore, inhabits the Mediterranean. End of lesson.
Lesson 6 of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lauren Huff. Elements of Conchology by William Ruschenberger. Lesson 6. Family of Cardiacea. Cardium, Donax, Cyclus, Corbus, Telina, Venus, Petricola, Veneripus, Mactra. Family of Inclusa. Lutraria, Maya, Bisomia, Hyatella, Solon, Sanguinolaria, Pholus, Teredo, Fistulana, Gastrocina, Clavigella, Aspergillum. Class of Mollusca Brachiopoda. General characters: Lingulo, Terebratula, Orbicula. Class of Mollusca tunicata, or Acephaloneuta. Biphora, Acidia, Botrytis, Pyrosoma. Class of Acephala continued. The family of Cardiacea is characterized by having the mantle open in front and prolonged posteriorly into two tubes, which are sometimes distinct and at others united in a single mass. One of them serves for respiration and the other for the passage of excrement. This mode of conformation is recognized in the shell by the impression made by the attachment of the edge of the mantle, called the pallial line, which before joining the posterior muscular impression or cicatrix, curves more or less deeply inwards. In all these mollusks there is a transverse muscle and a foot, which generally enables the animal to crawl. The species of Cardiaceae that have long tubes ordinarily live buried in the sand or mud. In this family we place Cardium, Donax, Cyclas, Corbus, Telina, Lucina, Venus, Petricola, Mactra, etc. genera, which for the most part are very numerous in species. The Cardia. Cardium are chiefly characterized by the hinge, which consists of two small teeth in each valve, situate in the center, and a projecting plate or tooth placed at some distance in front and behind. The shell is equivalve, convex, and furnished with ribs radiating from the summit towards the circumference, and when looked at from one side, Its general form reminds us of that of a heart, from the manner in which the summits (beaks) of the valves rise up, and curve inwards toward each other. The Donaces. Donacs have a hinge formed nearly like that of the cardia, but their shell is flattened, nearly triangular, inequilateral, and the summits are nearly vertical. Several small species are found on the coast of France, the shells of which are very pretty. The Cyclades. Cyclas have the same hinge, and are distinguished from the preceding by the rounded form of the shell, which is equilateral, that is, the two halves of the valve, situate on each side of the vertical line drawn through its summit, are alike, and striated transversely. One species, Talina cornea, is common on the coast of France. The general Sirena and Cyprina belong to this group. The Corbus are transversely oblong marine shells, which resemble the preceding in the hinge. Their external surface is very regularly marked by transverse ribs, crossed by diverging rays. The Talini. Talina closely resemble the Donaces, but they have the middle of the hinge armed with one tooth to the left and two to the right. The shell is slightly gaping. Like the Donaces, they have two long tubes, which can be entirely concealed within the shell when the animal contracts. Both live buried in the sand, and are found on the coast of France. The Venus is recognized by the hinge, the anterior and posterior plates of which, instead of being separated from the middle tooth as in the cardia, etc., are approximated in a single group beneath the summit. The shell is generally thick, moderately convex, and a little elongated. The species of this genus are very numerous. The genera Petricola and Veneripus resemble the Venus very much, and have obtained their names from living in the interior of stones which they perforate. The Mactrae differ from the other Cardiaceae in having an internal ligament, lodged in two pits in the hinge, corresponding with each other. There are some large species on our own coast. The fifth and last family of Testaceous acephalii or inclusa is composed of mollusks in which the mantle is only open at its anterior extremity, or near the middle, for the passage of the foot, and is prolonged posteriorly in a double tube. In other parts it is completely closed. The shell is always gaping at the extremities, and most of these animals live buried in the sand or mud. Sometimes they excavate holes in stones or wood. They are divided into Maya, Lutraria, Anatina, Glycemera, Solamia, Bisomia, Hyatella, Solon, Samobia, Pholus, Teredo, Fistulana, etc. The Lutrarii closely resemble the Mactrae, but their hinge is unprovided with lateral laminae, and their valves are very gaping, particularly behind, through which passes the thick fleshy cylinder formed by their double tube. A large species is found in the sand at the mouths of several rivers in France. In the Mailles there is a projecting plate in one of the valves, and a pit in the other joined by a ligament. The Anatinae have a small plate in each valve, giving attachment to a ligament. And the Solamiae and Glycemeri differ from the Mailles in their external ligament. The Bissomiae, in place of living in the sand, like the preceding, penetrate stones and corals and attach themselves to them by the aid of a byssus. Their shell is oblong, without a distinct tooth, and gaping about the middle of the inferior edge for the passage of the foot. The Hyatelli have nearly the same general form, but the tooth of the hinge is more marked. The Solons, commonly called razor shells, knife handles, from the cylindrical and elongated form of their shell, have the hinge furnished with an external ligament, and armed on each side with two or three projecting and very decided teeth. Their foot is conical, and is pushed out at the anterior extremity of the shell. They live in the sand, and bury themselves with great rapidity by the motions of their foot. The Pholides are distinguishable from all the preceding by one or more calcareous pieces, situate between the two valves of the shell near the hinge. The valves, which are broad and convex anteriorly, are elongated on the opposite side, and leave betwixt them a great oblique opening at each end. Their hinge resembles that of the Mailles. Their double tube is not retractile, and may be very much elongated. These animals inhabit tubes or long cells, which they excavate either in the mud, or stones, or wood. There are large species on the coast of France, in the West Indies, and on the coast of Peru. The pteridines, or shipworms, are celebrated for the ravages they commit by boring into ships' bottoms, piles of dikes, bridges, etc. These are mollusks with a very elongated and almost vermiform body, which is enveloped in a tubular mantle, open at the anterior and inferior part for the passage of the foot. It is provided posteriorly with two very short distinct tubes, and its base is furnished on each side with a movable stony plate. The shell is composed of two rhomboidal valves, but is very small, and covers only a very small portion of the mantle. It seems that the animal, by moving the extremity of its shell like an auger, excavates in submerged wood the hole which serves as its abode, and as it advances or buries itself deeper, it lines the excavation with a calcareous matter, so that in a short time it finds itself lodged in a stony tomb, which at first might be mistaken for a second shell. It begins its attack upon wood when very young, hence the external opening of its gallery is very small, but it digs on until the termination of its growth, and progressively augments the size of its dwelling. The two tubes which occupy the posterior extremity of the mantle always remain near the opening of the gallery, and through one of them it causes the water necessary for respiration and nutrition to enter, for it always remains in its hole, with the mouth down and the anus above. The common teredo, which is about 6 inches long, it is said was brought from the torrid zone, but it is widely spread in the seas of France, and infests the dikes of Holland to such an extent that its unperceived ravages have, more than once, been near producing terrible inundations. Vessels have been sunk by the holes bored through their bottoms by these animals. To guard against such accidents is one among the reasons why ships' bottoms are covered under water by thin sheets of copper. The Fistulinae also live buried in submerged wood or other analogous substances, and also line the interior of their hull with a calcareous mortar which constitutes a tube, completely closed at the large end, having more or less resemblance to a bottle. Like the pteridines, they have externally a small bivalve shell and 2 plates, which may be regarded as analogous to the operculum pieces of the gastropods. They inhabit the Indian seas. The gastrocini differ very little from the preceding. Their shell, which is unprovided with teeth, is very gaping in front, and their double tube, which can be retracted entirely within the shell, is susceptible of great elongation. They excavate holes in stones or masses of madrepore, and often line these holes with calcareous matter which, on becoming hard, constitutes a tube similar to that formed by the teredo and fistulana. We also place in this division the clavigella and aspergillum, which also construct a calcareous tube. In the first, one of the valves is collapsed by the tube, while the other remains free in its interior, and in the last the tube has, at its closed extremity, a disc perforated by a great many little tube-like holes, an arrangement which has obtained for it the name of watering-pot shell. Class of brachiopod mollusks. These mollusks are very analogous to the common acephaly. They are also provided with a 2-lobed mantle, and a bivalve shell. They have no foot, but in place of it 2 fleshy arms furnished with filaments, and susceptible of being unfolded externally, or drawn within the shell by folding spirally. Their branchiae are not distinct from the mantle, and the mass formed by their viscera is very small. They are unprovided with organs of locomotion, and live attached to submarine bodies. The principal genera composing this group are the Lingula, Terebratula, and Orbicula. The Lingulae are provided with a long fleshy peduncle, one extremity of which is generally attached to the rocks these animals ordinarily inhabit, and the other is furnished with 2 oblong flattened valves. Their arms, which are inserted in the sides of the mouth, are very long, and the branchial vessels are distributed on the internal face of the mantle, and there form on each side a series of small parallel folds. They are found in the Asiatic seas. The Terebratulae have 2 unequal valves joined by a hinge, and one of them has a hole through its summit, for the passage of a fleshy peduncle, by means of which the animal attaches itself. Their branchiae are less distinct than the Lingulae, and consist simply of a vascular network spread over the internal face of the mantle, but their muscular system is more developed, and there is found in the interior of the shell a small solid frame, the structure of which is sometimes very complicated. Its chief uses are to afford attachment to muscles, and to assist in separating the valves. Some living Terebratulae are found in the South Seas, but they abound most in the fossil state, and are found in the most ancient fossiliferous strata or layers of the earth's crust. The Orbiculae have 1 round conical valve, like the shell of the Patelli, while the other is flat and perforated for the passage of a very small peduncle. The conformation of their arms and the arrangement of their branchial vessels very closely resemble those of the Terebratulae. Class of Mollusca tunicata, or acephala without shells. The acephalous mollusks without shells, which have also been called tunicata, differ much from all the preceding in their general form, as well as in many important particulars of their organization. Their mantle consists sometimes of a simple tube open at both ends, and sometimes of a sac. Their branchiae present in different forms, but always very little developed, and are never divided into 4 leaflets or laminae, as in the ordinary acephaly, or lamellibranch testacea, among which they are placed by many authors. They have neither foot nor arm, and they evidently form the connecting link between the mollusks we have just described and inferior animals, which are ranged among the polypi in the branch of zoophytes. The Biphori, of all the tunicata, possess the most complicated organization. Their mantle is tubular, furnished with transverse muscular bands, and enclosed in a transparent, cartilaginous envelope. Both extremities are open, and the posterior orifice is supplied with a little valve, so arranged as to admit the water, but not to allow its escape. The mouth is placed in the tube formed by the mantle towards its anterior extremity, and the heart, liver, and other viscera are united into a small mass near this opening. The anus is situate far behind, and the only branchia, which is formed of a membrane transversely plaited, extends obliquely from the superior to the inferior parietes of the pallial cavity. The water which traverses this tube consequently laves the respiratory apparatus, and the animal moves by forcibly expelling it from the side of the mouth. Hence we see it must necessarily swim backwards. When fully grown these mollusks are free, but at birth they are frequently united to each other, forming a long chain, and swim in this manner for a long time. It seems that the individuals thus united, after becoming free or separated, produce young which are not joined together in a chain, as just described, and differ from them in form, and that the young arising from the last are united and similar to the first, so that in these singular animals there is the most remarkable alternation, the same form and the same mode of existence not being transmitted from one generation to the other, but constantly returning to the second generation. The Biphorii are found in the Mediterranean and in the warmer regions of the ocean. They frequently emit a phosphoric light. The simple Ascidiae cannot move like the Biphorii, but live attached to rocks. Their mantle is in the form of a sac with 2 orifices, and the interior of this cavity is lined with a network composed of the branchial vessels. The mouth and the little bag or sac containing the viscera are attached to the bottom of the great branchial cavity, and the anus is found near one of its openings. Other tunicata, closely resembling the preceding in their organization, live united in a common mass, and for this reason they are designated under the name of Ascidia composita, or aggregata. A gelatinous or cartilaginous tissue encloses a great number of these little beings, the surface of which presents a multitude of 6-pointed stars formed by their openings. Their propagation seems to be effected in 2 ways. Sometimes the mass grows by the development of their reproductive buds in this common tissue, sometimes the young formed in an ovary are expelled externally and swim about free or separately for some time, until they become attached to some submarine body where they establish a new colony. We give the name of Botrytis to a small aggregated tunicata of an oval form, which differ little from the preceding, except their branchial sac is open at both extremities, and the anal orifice terminates in a central cavity, around which 10 or 12 of these mollusks are grouped like the rays of a star. The Pyrosomi unite in great numbers, forming a large hollow cylinder, open at one end and closed at the other, which swims in the ocean by the alternate contraction and dilation of the animals that compose it. In their individual organization they are similar to the preceding. Of the parts of shells. We have now brought our history of the mollusca to a close, but with the view of imparting clearer notions on the subject of conchology, or history of shells, we shall add here a few words in relation to the parts of shells. It is absolutely necessary to understand these parts before we can comprehend the descriptions given by conchologists, or be able to describe the shells in such a way as conchologists can recognize them. The most simple form of a shell is the cone. The apex of the cone is oblique and eccentric. In the limpets, patella, argonaut, and nautilus, the apex is directed towards the head, but in most other mollusks towards the opposite extremity of the body. A shell may consist of one piece, as in the inopercular univalves, that is, univalves without an operculum or door. A shell may consist of 2 pieces, as in the opercular univalves, univalves with an operculum, and in most bivalves. A shell may consist of 3 pieces, as in the Terebratula. A shell may consist of 4 or more pieces, as in some of the Phollides. A shell may consist of many pieces, in which case it constitutes a multivalve, as the chitin. The univalve shells are much more numerous than any others, both in genera and species, and it requires a considerable degree of attention to discriminate many of the species, as they run into each other so much. In the examination of univalve shells, the general outline or contour of the whole shell is the first particular to be attended to, as this leads to those distinctions necessary in the definition of simple, spiral, or turbinated shells, or more strictly according to the Linnaean method of discrimination, univalves with a regular spire and those without a regular spire. Univalve shells are classified principally from the shape of the aperture, taken in conjunction with the general shape of the shell. From the spire being lengthened or depressed, being with or without a canal, the length of the beak and its direction, together with the particular form of the outer or external lip, the color of shells only serves as a specific distinction, and, even in this respect, cannot in all cases be depended upon, although in others it is an unvarying test. The particular manner in which the spots are disposed frequently characterizes species. Apex is the summit, tip, or highest part of a shell. Base is the opposite extremity from the apex. In shells with a beak or rostrum, as the murex, it implies the tip of such beak. In shells without a beak it is understood to be the lower part, as before mentioned, opposite of the apex. In the patella and some others the base of the shell is that part on which it rests when it is laid upon its mouth. In the teredo and similar shells it is the wider end. Body of the shell is the first or lower whorl of the spire, in which the aperture is situated. This whorl is generally longer than the others. Front of the shell is that side where the aperture is situated. Back of the shell is the opposite side to that in which the aperture is placed. The venter or belly is the most prominent part of the lower whorl or body, generally situated in the vicinity of the lip over the aperture, and formed by the convexity of the aperture. In general, this term is only made use of in describing shells whose body is large in proportion to the size of the spire. Sides of a shell are the extreme edges of the shell, when viewed either in front or from the back. The right side is the one next to the observer's left hand when the shell is viewed in front, and the side with the aperture in it is the left side. The conical univalve shell is generally spirally convoluted, sometimes, as in the nautilus, in the same plane, but more usually in an oblique direction. As a general rule, the spiral univalve, if viewed in the position in which its inhabitant would carry it, if moving forward from the observer, is twisted from the apex downward, from left to right, the spire being directed obliquely towards the right. In some genera, for example, Clausilia, from the Latin clausus, shut, and Physa, from the Greek phusa, a bubble, the shell is twisted in an opposite direction. Such shells are called perverse or sinistral. The aperture, or mouth, is that part of the lower whorl of the body through which the animal protrudes itself. This is one of the principal means of distinguishing the genera of univalve shells, and it varies much in its form. Some apertures are rounded, others semilunar, others angular, etc. Some apertures have a canal at their base, and others are without it. In various genera, the aperture extends the whole length of the shell, as in Ovula, Cypria, and some of the cones with depressed spires. In several individuals, the aperture is either entirely open, or closed by an operculum or door, which is usually affixed to the foot of the animal. When without a notch or canal, the aperture is said to be entire. The aperture has two lips or borders. The internal lip or border is on the side of the aperture, formed by the columella, and the external or outer lip or border is opposite, as in the Pleurotoma. Canal or gutter is the space or hollow formed by the prolongation of the two lips of the aperture. Some shells have two canals, one situated at the point where the outer lip and body join. Beak or rostrum is that lengthened process in which the canal is situate. This process is not so conspicuous in some of the species of Voluta, but is more marked in the genera Murex, Fusus, etc. The columella or pillar is that process which runs through the center of the shell in the inside, from the base to the apex, and around which the whorls or wreaths of the spire are wound. When the columella is marked by ridges or folds, as in Auricula and Oliva, it is said to be plicated or plaited, but when it is smooth, it is simple. Pillar lip is a continuation of the glassy process with which the aperture is lined, and expanded on the columella. It is also called the inner or internal lip. The outer lip, or external border, is the expansion or continuation of the body of the shell, on the left margin of the aperture, and also lined with the glossy process of the aperture. Spire consists of all the whorls of the shell except the lower one, which, as before observed, is termed the body of the shell. This spire is a prominent feature of the univalve, and upon its being elevated, depressed, etc., depends much of the generic and specific definition of these shells. It is a remarkable circumstance that many of the young shells have not the same number of wreaths as the adults, from which it would appear that the part of the animal nearest the apex never increases in size. The number of wreaths cannot at all times be depended upon. A full-grown shell may, however, be known from the outer lip, which has generally an unfinished appearance in young shells. Indeed, in all the land and freshwater shells, it is a distinct criterion, as they are never complete in the form of the outer lip till full grown. Whorl is one of the wreaths or volutions of the shell. Depressed spire is when the spire is very flat, as in the shells of the genus Planorbis. Involuted spire is where the spire is concealed in the inside of the first whorl or body, as in some of the Nautili, Cyprii, Ovuli, etc. Suture of the spire, or whorls, is a fine spiral line or seam formed by the joining together of the whorls. It is sometimes crenulated, undulated, waved, or sulcated, grooved, and not unfrequently elevated or projecting. Reversed, or heterostrophe spire, is when the volutions of the spire revolve in the same manner as the common corkscrew, or when the aperture is placed downward, the nature of the spire runs upward from the right hand to the left. Chambers are the cavities, divided by partitions at regular or irregular intervals, as in the nautilus. Umbilicus is a circular perforation in the base of the lower whorl or body. Sub-umbilicated shells are those which have the umbilicus covered, in a greater or less degree, by a thin process, which in some almost entirely closes the aperture or mouth. This character is most commonly to be met with among species of Buccinum and Murex. Umbilical fissure is a groove extending from the umbilicus. Shells which have no umbilicus are termed imperforate. Siphunculus, little siphon, is that small round perforation which forms a communication between the chambers in the nautilus, and penetrates through the whole spire of the shell. Varices are transverse ribs which cross the whorls of shells in some species of Buccinum, Murex, etc. Varices are formed by the periodical growth of the shells, these being the margin of the outer lip, to which the animal has attached its periodical enlargements. In some species they have more of the form of sutures than ribs, this owing to the margin of the outer lip being but slightly developed. Ribs are those longitudinal and transverse protuberances which are in many of the univalve shells. Teeth of univalves, according to Colonel Montague, are not properly tooth-shaped protuberances, but are fine white laminae or ridges, running spirally backwards, in a direction parallel to each other. Those on the exterior lip may, in most instances, be traced through the outside of the shell, and are nearly alike in length. Epidermis is a skin, or cuticle, covering the exterior surface of many shells, destined by nature to protect their surface from being injured. True bivalve shells are peculiar to the acephalous mollusca, and their presence is constant, although they are in a few instances too small to cover the whole body, and in the ship-borers, Teredo, exist only as small instruments, limited to the function of excavating the burrows inhabited by these mollusks. But all the species, in which the bivalve shell is inadequate to the protection of the whole body, derive extrinsic defense by burrowing in sand or stone or wood, and they also commonly line their burrows with a layer of smooth and compact calcareous matter, forming a tube. This calcareous tube, in some cases, is of considerable size and thickness. In the Clavigella, one valve, and in the Aspergillum, both valves, are soldered to this tube, which in the latter presents a peculiar modification of its exposed extremity, which resembles the end of the spout of a watering pot. No two shells can present a greater contrast than do those of the Placuna and Aspergillum, yet the organization of their respective constructors is essentially the same. In a classification of shells, the calcareous tubes of the Dentalium, Serpula, Aspergillum, Vermetus, etc., would be associated in the same general group, but it needs only to observe how these products of animals, belonging not only to the different classes, but to distinct primary divisions of the animal kingdom, are arranged in the cabinets of collectors, to be convinced that conchology is a classificatory science, apart from malacology, the science of mollusks, no longer exist. With regard to the structure and physiological relations of bivalve shells, it may be observed first that in all acephalous mollusks which breathe by distinct lamellated gills, branchiae, lamella branchiata, one valve corresponds to the left, the other to the right side of the animal, but in the branchiopodous bivalves, one valve is applied to the ventral and the other to the dorsal aspect of the animal. In all the lamellibranch bivalves which are free, the two valves are symmetrical, and the shell is termed equivalve. In all those which adhere by one of their valves to foreign bodies, this valve is deeper and larger than the unattached valve. Such shells are termed inequivalve. Of these acephalans which are attached to foreign bodies by means of a byssus, some, as the Tridacna, are equivalve, and both valves are notched to form the hole for the passage of the byssus, while others, such as the pecten and avicula, are inequivalve, the byssus passing through a groove in the right valve. If the shell of the common cockle be examined, each valve will be seen to be produced in a conical prominence bent towards, and nearly meeting at, that part by which the valves are joined together. These prominences are termed the umbones, or sometimes beaks. The apex of the umbo corresponds to the apex of the univalve shell, and is the point at which the development of the bivalve commences. When the apex is directed in the transverse plane of the shell, and so placed that a division of the shell in that plane through the apices shall divide the valve into two equal parts, the shell is termed equilateral. Of this form the pecten is an example. When upon a similar division a slight difference is observed in the two valves, the shell is termed subequilateral, but where the difference is well marked it is an inequilateral bivalve. When the apex is bent, as is commonly the case out of the transverse plane, it is always directed more or less towards the anterior part of the shell. If such a bivalve such as the Cytherea, or Isocardia, be held before the observer with the umbones directed forward and the hinge above, in the position in fact which the living animal would place itself if it were creeping forward from the observer, the right valve will of course correspond with the right hand of the observer, and the left with the left. When the circumference or margin of one valve fits exactly at every part that of its fellow, it is said to be regular or entire, but if it be notched at any part so as not to come in contact with the corresponding part of the opposite valve, it is irregular or emarginate. Besides the parts mentioned, we shall find in most cases, and anterior to the apices of the beaks, a depression of variable extent and depth. This is the lunule. It may be cordiform or crescentic, lanceolate, oblong and gradually tapering towards each extremity, oval, deep, superficial, etc. Behind the beaks is another depression, longer and narrower than the lunule, and which is called the fissure, and its margins are named lips of the fissure. Behind the fissure there is sometimes a small depression called the suture. The general, more or less convex surface of each valve is called the venter or belly, which terminates in the limb, circumference or margin. The most important part of the margin is that which is modified to form the joint or hinge upon which the two valves open and shut. This part is called the cardinal edge, and generally presents certain prominences and depressions, the projections of one valve interlocking with the depressions of the other. The projections, or teeth, together with the cavities, or cardinal pits, are very regular in their formation in each genus and species of bivalve, but what is of more importance is, that every modification in the structure of the hinge is generally found to coincide with some recognizable and more or less important difference in the organization of the soft parts, so that conchologists have justly attached great value to the characters derivable from the hinge, especially for the purpose of generic distinctions. When the teeth are situate beneath the apex, or centre of the hinge, they are called cardinal or primary. When they are removed from the centre of the hinge, they are named lateral teeth. When two only are present, one is called anterior, the other posterior. When there are three, they are distinguished respectively as anterior, median, or middle, and posterior teeth, but when the hinge is composed of a great number of teeth, it is said to be serial, as in arca. Some hinges have no visible teeth, and are termed inarticulate. The direct medium of union of the two valves is a dense fasciculous bundle of elastic fibers, generally of a brown color, called ligament, or elastic ligament. The fibers of this part are attached by their extremities to the two valves, which in most cases present a particular depression for their reception. The ligament is always so long as to prevent the actual closing of the valves, except when its elasticity is overcome by a certain force, as by that of the contraction of the adductor muscle or muscles. Thus the inorganic power of elasticity is made the direct antagonist of a vital and muscular contraction, and as the open or expanded condition of the bivalve shell is that which the exigences of the animal most constantly require, it is assigned to a force which can act without ever causing fatigue, while the occasional or protective action of forcibly closing the valves is due to an action under the immediate control of the will or instinctive sensation. The modifications of the internal surface of a bivalve shell are caused by the structure of the animal inhabiting it, hence they afford the characters by which the habits of an extinct genus may be to a great extent determined. The pallial impression shows the development of the muscular margin of the mantle. End of Lesson 6. Recording by Lauren Huff. Glossary of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lauren Huff. Elements of Conchology by William Ruschenberger. Glossary. Conchology. Abdomen. The belly, the cavity which contains the stomach, liver, etc. Abdominal. Belonging or relating to the belly. Acephala. From the Greek a, without, and cephalai, head, without a head. The Latin word animalia, animals, is understood, therefore acephala means animals without a head. Acephaly. Latin. Plural of acephala. Acephalus. Headless. Belonging or relating to acephaly. Acetabulifera. From the Latin acetabulum, a little cup, and fero, I carry. Applied to those cephalopods that have cups or suckers on their arms or tentacles. Acatena. From the Greek achates, agate, name of a genus of terrestrial gastropods, sometimes known as the agate snails. All the species of this genus are oviparous, and one, the Acatena zebra, figured on page 41, lays eggs with a hard white shell and as large as those of a sparrow. Adductor muscle. From the Latin adduco, I draw towards. The muscle which draws the valves of a bivalve shell toward each other is so called. Adnate. Adhering or growing together. Agglutinins. Latin. Gluing. A gastropod which has the faculty of causing other species or parts of shell to adhere to it is so named. Aggregata. Latin. Gathered together. Agrestis. Latin. Rural, wild. Acara. From the Greek a, without, and kieras, horn, hornless. Name of certain mollusks that have very short tentacles, or none at all. Acari. Plural of acera. Alated, winged. Alimentary canal. The intestinal tube is so called because it is the medium through which food is conveyed into the body. Aluco. Specific name of a shell. Ambient, surrounding, investing. Ambrette. From the French amber, amber. Name of a shell supposed to resemble amber. Ammon. From the Greek ammus, sand. Name of a heathen divinity whose temple was in the sands of the desert. Ammonites. Ammonites, vulgarly called snakestones, are fossil shells found in the strata of the secondary formation, varying from the size of a bean to the dimensions of a coach wheel. Their name is derived from their resemblance to the horns on the statue of Jupiter Ammon. Ampullaria. From the Latin ampulla, a bottle or jug, anything puffed or swelled out. Ampullary, plural of ampullaria. Anatifa. From the Latin anas, in the genitive case, anatis, a duck, and pharaoh, I bear. A genus of brachiopod mollusks. It was for a long time believed that certain ducks were derived from the metamorphosis of these animals, and for this reason they were called anatifa. Anatina. Name of bivalves which resemble the solens. Angiostoma. From the Greek aegeon, a vessel, and stoma, mouth. Anodonta. From the Greek a, without, odos, in the genitive, odontos, tooth, without teeth. Systematic name of a kind of mussel, the shell of which is without teeth. Anodonti, plural of anodonta. Anomia. Greek a, without, and nomos, law. Systematic name of certain mollusks. Anomy, plural of anomia. Anus, Latin. The inferior opening of the rectum for the passage of excrement. Aorta. The principal artery of the body is so called. Aortic. Belonging or relating to the aorta. Aperture. The mouth or opening of the shell. Apex. The tip or point of the spire of a shell. Aplesia. From the Greek aplusia, uncleanness. That which cannot clean itself. Systematic name of the sea hares, to which the ancients attributed many fabulous properties. Applesii. Plural of applesia. Apparatus. Latin. Formed from ad, for, and parere, to prepare. A collection of organs or instruments for any operation whatever. Aquatica. Latin. Aquatic, belonging or relating to the water. Arca. Latin. A chest, an ark or coffer. Systematic name of certain mollusks. Archi. Plural of arca. Areola. A small area or circle. Argonaut. From the Greek argo, the name of a vessel, and nautes, a navigator. The Grecian princes who attempted the conquest of the Golden Fleece in the ship Argo, under the command of Jason, were called Argonauts. Systematic name of a cephalopod. Argonauta. Latin. Argonaut. Artery. A blood vessel that conveys blood from the heart to the various organs of the body. Articulata. Latin. Having joints. The word animalia, animals, being understood, articulata means animals with joints, and is applied to insects, etc. Articulate. Animals. Having joints. Articulated, having joints. Ascidia. From the Greek oskos, a bottle or pouch. Systematic name of certain mollusks. Ascidii, plural of ascidia. Aspergillum, Latin. A watering pot. Auditory. Belonging or relating to the sense of hearing. Auricle. Name of one of the cavities of the heart. Auricula. From the Latin auris, an ear. Name of a shell from its resemblance to the human ear. Auriculoventricular opening. The aperture betwixt the auricle and ventricle of the heart is so called. Avicula. From the Latin avis, a bird. Name of a shell. Batrachian. From the Greek batrachos, a frog. Belonging to that order of reptiles which includes frogs and toads. Beak. The continuation of the body of univalves in which the canal is situate. Belemnites. From the Greek belemnon, a dart. A genus of fossil dibranchiate cephalopods, the shells of which are chambered and perforated by a siphon, but internal. They are long, straight, and conical, and commonly called thunderstones. They are often found in chalk. Bifora. From the Greek bis, double, and phorid, I bear. Bifori. Plural of bifora. Bivalve. From the Latin bis, two, and valvi, doors. Shells composed of two pieces united by a hinge are termed bivalves, as for example clams, oysters, mussels, etc. Borealis. Latin. Northern. Belonging or relating to the north. Botrytis. From the Greek botris, a bunch of grapes. Brachiopod. From the Greek brachion, an arm, and pous, foot. Brachiopoda. See brachiopod. Branchia. Latin. A gill. Branchii. Plural of branchia. Branchial. Belonging or relating to the branchii or gills. Buccal. From the Latin bucca, the cheeks. Belonging to the cheeks. Buccinum. Latin. A trumpet or horn, a shell. Buccina. Latin. Plural of buccinum. Buccinoides. From buccinum and the Greek eidos, resemblance. Systematic name of a family of shells, the characters of which resemble those of the buccinum. Byssus. From the Greek busos, a fine flax. A bundle of silky filaments, secreted by a gland at the foot of certain bivalves, and serving as an organ of adhesion to submarine rocks and other foreign bodies. Calcareous. From the Latin calx, lime. Partaking of the nature of lime. Calmaries. From an old French word calmar, an inkstand or pen case. This word is from the Latin calamus, a pen. Name of a family of cephalopods. Calyptria. From the Greek calyptra, a covering. Name of a genus of gastropods. Calyptrii, plural of calyptria. Camarines. From the Latin camera, chamber. Name of certain microscopic shells. Capillary. From the Latin capillus, a hair. Hair-like. Capulus. Latin. A hilt or handle. Capuloides. From the Latin capulus and the Greek eidos, resemblance. Capuloida. Same as capuloides. Cardia. Latin. Plural of cardium, a cockle. A genus of the family of Cardiacea. Cardiac. From the Greek cardia, the heart. Belonging or relating to the heart. Cardiacea. From the Latin cardium, a cockle. Systematic name of a family of acephalous mollusks. Cardiaceae. Plural of Cardiacea. Cardita. Genus of the family of Cardiacea. Cardinal tooth. From the Latin cardo, a hinge. Belonging or relating to the hinge. Cardium. Latin. A cockle. Cartilage. Gristle. Cartilaginous. Belonging or relating to cartilage. Carinaria. From the Latin carina, a keel. A genus of heteropodous gastropods. Carinate. From the Latin carina, a keel. When a surface has a longitudinal elevated line like the keel of a boat. Carnivorous. From the Latin caro, in the genitive case carnis, flesh, and voro, I eat, flesh-eating. Cassis. Latin. A helmet. Cava. Vena. A name given to the two great veins of the body which meet at the right auricle of the heart. Cephalic. From the Greek cephalli, the head. Belonging or relating to the head. Cephalopods. From the Greek cephalli, head, and pous, in the genitive case podos, foot. A class of mollusks which have the head situated between the body and feet. Cephalopoda. Latin. Cephalopods. Cerita, cerithium, comma. See page 54. From the Greek chow, I gape. A cockle. Chamacia. From comma, a cockle. Systematic name of a family of acephalous mollusks. Chitin. From the Greek chitin, a garment. Name of a cyclobranch gastropod. Chondrus. From the Greek chondros, cartilage. Name of a genus of gastropods. Choroid. From the Greek chorion, and eidos, resemblance. Name of the membrane of the eye which lines the sclerotica. Cicatrix. From the Latin cicere, to conceal. The scar which remains after the healing of a wound. The muscular impressions or points where the adductor muscles are attached in bivalve shells are called cicatrices. Cicatrices. Plural of cicatrix. Ciliated. From the Latin cilium, eyelash. Fringed like the eyelashes. Cinereous. Latin. Like ashes, ash-colored. Cirrhopoda or Cirripedia. From the Latin cirrus, a tendril, a curl, and the Greek pous, podos, foot. Systematic name of a class of mollusks. They are characterized by having a number of long, curled, articulated processes, analogous to the feet of the crustaceans, which project from the central aperture of the multivalve shell protecting them. They are commonly called barnacles. This class includes the genus Anatifa and Balanus. Clausilia. From the Latin clausus, closed. A genus of land shells, so named because the aperture of the shell is closed internally by a spiral lid. Clavigella. From the Latin clavis, a nail. Cleodora. Name of a genus of pteropod mollusks. Cleo. From the Greek kleos, glory. Cecum or cecum. From the Latin cecus, blind. The blind gut, so called from its being perforated at one end only. Columella. Latin. A little column or pillar. The axis of a shell from top to bottom. Composita. Latin. Compounded. Conchifera. From the Greek conchi, shell, and the Latin fero, I bear. Shell-bearing. Applied to mollusks with bivalve shells. Conchilia. Belonging or relating to shells. The name of a dye. Conchology. From the Greek conchi, a shell, and logos, a discourse. The science of shells. Conus. Latin. A cone. Cor. Latin. The heart. Coralliophaga. Latin. Formed from the Greek corallion, corral, and phagian, to eat. Coral eating. Corbus. Latin. A twig basket or pannier. Name of a genus of acephalous mollusks which have the external surface of the shell marked by ribs and transverse lines resembling basket work. Cordiform. From the Latin cor, in the genitive case cordis, heart, and forma, shape. Heart-shaped. Cornea. From the Latin cornu, horn. One of the coats of the eye, so called because it has some resemblance to horn. It is the anterior transparent part through which light passes. Cranial. From the Latin cranium, the skull. Belonging or relating to the skull. Crenulate, crenulated, and crenulation. From the Latin crena, a notch. Having rounded teeth, or a rounded tooth or notch. Crepidula, Latin, a slipper. Crepidulae, plural of crepidula. Crustacea. From the Latin crusta, a hard covering. A class of free articulate animals, with articulated limbs, a branchial respiration, and a dorsal or ventricle heart. Crustacea, plural of crustacea. Crustaceans. Crystalline lens, the lens of the eye. Cyclus, from the Greek kuklos, a circle. A genus of freshwater gastropods, so named from the circular form of the shell. Cyclades, plural of cyclus. Cyclobranchiata, from the Greek kuklos, a wheel, and branchia, gills. Name of an order of mollusks. Cyclostoma, from the Greek kuklos, a circle, and stoma, mouth, a genus of gastropods. Cyclostomy, plural of cyclostoma. Cymbulia, from the Greek kumbalon, hollow, a genus of pteropoda, commonly called the gondola. Cypria, from the Greek kupris, Venus. Name of a genus of gastropods, a cowrie. Cyprii, a plural of cypria. Cypricardia, from the Greek kupris, Venus, and cardium, a cockle, a genus in the family of Chamacia. Cyprina, a genus belonging to a group of Cyclades. Cyrena, a genus of the family of Chamacia. Delphinula, a little dolphin. Name of a genus of the family of Trichoides. Dentate, from the Latin dens, tooth, marked with tooth-like projections. Depressed shell, when the spire is very flat. Diaphragm, midriff. Dibranchiata, from the Greek dis, two, and brachos, gills, two-gilled. Name of a division of cephalopods. Dibranchial, having double gills or branchiae. Digitation, from the Latin digitus, finger, a process resembling a finger. Dimiaria, from the Greek dis, two, and muon, muscle. All those bivalves are so called which have two distinct and separate adductor muscles, and consequently two corresponding muscular impressions on each valve. Dimiarii, plural of dimiaria. Diphyllidia, from the Greek dis, two, and phulon, leaf. Name of a division of gastropods. Discoid, from the Greek diskos, a quoit, and eidos, resemblance. This term is applied to those univalve shells of which the whorls are disposed vertically on the same plane so as to form a disc, as in the planorbis. Dolabella, Latin, a little axe. Name of a genus of gastropods. Dolium, Latin, a tun or tub. Name of a genus of gastropods. Donax, Latin and Greek, a reed, an arrow. Name of a genus of mollusks of the family of Chamacia. Donaces, plural of Donax. Doris, a sea goddess, the daughter of Ocean and Thetis. Name of a genus of nudibranch gastropods. Dorsal, from the Latin dorsum, the back, belonging or relating to the back. Edulus, Latin, edible, that which may be safely eaten. Emarginula, from the Latin e, from, and margo in the genitive marginis, border or margin. A genus of gastropods characterized by a shell of simple conical form, but having a narrow fissure extending from the margin to near the summit. Entire opening. When the opening of a shell has neither a notch nor canal on its margin, it is said to be entire. Eolidia, name of a genus of gastropods. Eolidae, plural of Eolidia. Epidermis, from the Greek epi, upon, and derma, skin, the cuticle or scarf skin. Equivalve, when the two valves of a bivalve shell are symmetrical, they are said to be equivalve. Etheria, from the Greek aitho, I shine. Name of a genus of the family of Ostrachia. Etherii, plural of Etheria. Excretory, applied to any vessel or duct which transmits the fluid secreted by a gland, either externally or into the reservoir designed to receive it. Extravasation, from the Latin extra, out of, and vasa, vessels. Escape of fluids from vessels containing them and the effusion of those fluids into the surrounding textures. End of Glossary Part 1. Recording by Lauren Huff.
Glossary D-N of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Elements of Conchology by William Ruschenberger. Glossary D-N. Delphinula, Latin, a little dolphin. Name of a genus of the family of Trochoids. Dentate, from the Latin dens, tooth, marked with tooth-like projections. Depressed shell, when the spire is very flat. Diaphragm, midriff. Dibranchiata,
From the Greek dis, two, and brachos, gills, two-gilled. Name of a division of cephalopods. Dibranchial. Dibranchial. Having double gills or branchiae. Digitation. From the Latin digitus, finger. A process resembling a finger. Dimyaria. From the Greek dis, two, and one, muscle. All those bivalves are so called which have two distinct and separate adductor muscles, and consequently two corresponding muscular impressions on each valve. Dimyariae. Plural of dimyaria. Diphyllidia. From the Greek dis, two, and phullon, leaf. Name of a division of gastropods. Discoid. From the Greek diskos, a quoit, and eidos, resemblance. This term is applied to those univalve shells of which the whorls are disposed vertically on the same plane so as to form a disc, as in the planorbis. Dolabella, Latin, a little axe. Name of a genus of gastropods. Dolium, Latin, a tun or tub. Name of a genus of gastropods. Donax, Latin and Greek, a reed, an arrow. Name of a genus of mollusks of the family of Chamaceae. Donacis, plural of Donax. Doris, a sea goddess, the daughter of Ocean and Thetis. Name of a genus of nudibranch gastropods. Dorsal. From the Latin dorsum, the back. Belonging or relating to the back. Edilus, Latin. Edible, that which may be safely eaten. Emarginula. From the Latin e, from, and margo, in the genitive, marginis, border or margin. A genus of gastropods characterized by a shell of simple conical form, but having a narrow fissure, extending from the margin to near the summit. Entire opening. When the opening of a shell has neither a notch or canal on its margin, it is said to be entire. Eolidia. Name of a genus of gastropods. Eolidae, plural of Eolidia. Epidermis. From the Greek epi, upon, and derma, skin. The cuticle or scalp skin. Equivalve. When the two walls of a bivalve shell are symmetrical, they are said to be equivalve. Etheria. From the Greek aitheo, I shine. Name of a genus of the family of Ostracea. Etheriae. Plural of Etheria. Excretory. Applied to any vessel or duct which transmits the fluid secreted by a gland, either externally or into the reservoir designed to receive it. Extravasation. From the Latin extra, out of, invasa, vessels. Escape of fluids from vessels containing them, and the effusion of those fluids into the surrounding textures. Fasciculus. Latin, a bundle. Fasciculi. Plural of fasciculus. Fibrous. Composed of fibers. Filiform. From the Latin filum, a thread, thread-like. Firola. Name of a genus of gastropods. Firolae. Plural of Firola. Fissurella. From the Latin findo, I split. A genus of gastropods, having a split or opening in the top of the shell. Fissurelle. Plural of Fissurella. Fistulana. From the Latin fistula, a pipe. Name of a tribe of mollusks. Fistulanae. Plural of Fistulana. Follicle. From the Latin follis, a bag, a little bag or sac. Foraminifera. From the Latin foramen, a hole, and fero, I bear. Name of a tribe of very minute shells. Formation. A geological term applied to a group of deposits or strata apparently referable to a common origin or period. Fossa. Latin, a pit, a hollow. Fossae. Fossae. Plural of fossa. Fragilis. Latin. Fragile, easily broken. Fucus. Latin. Seaweed. Fussus. Latin. A spindle. Gallia. Latin. A helmet. Ganglia. Plural of ganglion. Ganglion. From the Greek gaglion, a knot. An enlargement or knot in the course of a nerve is termed a ganglion. Ganglionic, consisting of or relating to ganglia. Gastropods — from the Greek gaster, belly, and pous, foot. Systematic name of a class of mollusks, comprehending those which have a ventral muscular disc, adapted for creeping. Gastropoda.—Latin. Gastropods. Gastropodas. Belonging or relating to gastropods. Gastrocana—from the Greek gaster, belly, and kaino, I gape. A genus of bivalve mollusks in which a large hiatus or gape intervenes between the closed valves on the ventral aspect of the animal. Gastrocanae.—Plural of Gastrocana. Genus. Latin. A kindred, breed, race, stock, lineage, or family. Genera. Latin. Plural of genus. Gland. An organ for the purpose of secreting a peculiar fluid, etc. Glandular. Relating to glands. Glaucus. From the Greek glaukos, blue. Name of a genus of mollusks. Globose. Globe-like, globular. Glycymera or Glycymeris. Name of a genus of bivalve mollusks. Gryphaea.—From the Greek grupos, incurved. A genus of mollusks of the family of Ostracea. Haliotis.—From the Greek als, the sea, and ous, the ear. Name of a genus of gastropods. Haliotides. Plural of Haliotis. Harpa.—Latin. A harp. Helicina.—Name of a genus of gastropods. Helix.—From the Greek elix, a spiral, a whorl. Name of a genus of gastropods. Helicis. Plural of helix. Hermecyclostoma.—From the Greek emesis, half, kuklos, round, and stoma, mouth. Name of a tribe of gastropods. Herbivorous.—From the Latin herba, plants, and voro, I eat. Plant eating, applied to animals that feed on vegetables. Hermaphrodite.—From the Greek ermis, Mercury, and Aphrodite, Venus. An organized body, combining in reality or appearance the characteristics of both sexes. Heteropods.—From the Greek heteros, various, and pous, foot. The name of an order of gastropods. Heteropoda.—Latin. Heteropods. Heteropodos. Belonging or relating to the heteropods. Hiatus.—Latin. A yawning, a gape. Hipponyx.—From the Greek ippos, a horse, and onyx, nail. Name of a genus of gastropods. Hyalaea.—From the Greek ualos, glass. A genus of beautiful pteropods, remarkable for the transparency and delicacy of the shell. Hydatus.—Latin. Formed from the Greek udor, water. Specific name of a mollusk. Imbricate.—Placed like the tiles of a house. Inclusa.—From the Latin includo, I enclose. Name of a tribe of acephalous mollusks. Incurved.—When a part is turned inwards. Inequilateral.—When the anterior and posterior sides make different angles with the hinge. Inequivalve.—Where one valve is more convex than the other, or dissimilar in other respects, as in the common oyster. Inferobranchiata.—From the Latin, inferus, below, and branchia, gills. Name of an order of gastropods which have the branchiae below the mantle. Integument.—From the Latin, tegere, to cover, the covering, the skin. Interganglionic.—Applied to nerves which are between ganglia. Internode.—The space between one knot or joint and another. Interrupted.—Divided, separated. Intorta.—Latin. Twisted inwards. Invertebrata.—Latin. Formed of in, without, and vertebra, a bone or joint of the spine or backbone. A division of the animal kingdom embracing mollusks, insects, and other animals which have no vertebrae or internal bony skeleton. Invertebrate.—Without vertebrae. Involute.—Having the exterior lip turned inwards at the margin, as in the Cypraea. Involution.—That part which involves or enwraps another. Isocardia.—From the Greek isos, like, and cardia, heart. Name of a genus of Chamacea. Isocardiae.—Plural of Isocardia. Anthina.—From the Greek ianthon, violet colour. A genus of the family of trochoids. Labio. From the Latin labium, lips. Belonging or relating to the lips. Lacineate. Jagged or cut into irregular segments. Lacunose. Having the surface covered with pits. Lamella. Latin. A little thin plate of peas. Lamellae. Plural of lamella. Lamellibranchiata. From the Latin lamella, a thin plate, and branchia, gills. An order of acephalous mollusks. Lamellibranch. Belonging to the Lamellibranchiata. Lamina. Latin. A plate or thin piece of metal or bone. Laminae. Plural of lamina. Laminated. Divided into distinct laminae. Lapillus. Latin. A little stone. Lenticular. From the Latin lenticula. A little lens, a lentil. Shaped like a lens. Lima. Latin. A file. Name of a genus of the family of Ostracea. Limax. Latin. A slug, a snail. Limasis. Plural of limax. Limb. The margin of bivalve shells. Limnaea. From the Greek limne, a pool. Name of a genus of freshwater snails. Linear. Composed of lines. Lineate. Marked with lines. Lingula. Latin. A little tongue. Name of a genus of bivalves. Lingulae. Plural of lingula. Lithodermis. From the Greek lithos, stone, and demo, I build. Name of a genus of bivalves found in rocks and stones, inhabiting cavities which they form for that purpose. Lithodermi. Plural of lithodermas. Littoral. Belonging to the shore. Littorina. From the Latin litus, the seashore. A genus of the family of trochoids. Littorius. Latin. Belonging or relating to the seashore. Lobated. Rounded at the edges. Lobe. A round projecting part. Loligo. Latin. A calmary. Loligopsis. A calmaret. A little calmary. Longitudinal. The length of the shell from the apex to the base. Lubricity. Smoothness of surface, slipperiness. Lunated. Formed like a half moon. Lunulated. Crescent shaped. Lunule. A crescent-like spot or mark situated near the anterior and posterior slopes in bivalve shells. Luniform. In the shape of crescent or half moon. Lutraria. Genus of the family of Inclusa. Mactra. Latin. A kneading trough. Name of a genus of bivalves. Madrepore. A hybrid compound of the French madre, spotted, and Latin porus, a pore. Name of a genus of zoophytes. Magalus. Name of a genus of gastropods. Magus. Latin. Magical. Malleus. Latin. A hammer, a genus of Ostracea. Mandible. From the Latin mandibula, a jaw. The jaw of a bird. Mantle. The external fold of the skin of mollusks. Margaritifera. Latin. From margaritum, a pearl, and fero, I bear. Pearl bearing. Margin. The whole circumference or outline of the shell in bivalves. Marginated. Having a prominent margin or border. Mediterranea. Latin. Belonging or relating to the Mediterranean. Medullary. From the Latin medulla, the marrow. Belonging or relating to nervous matter. Melania. From the Greek melas, black. Genus of freshwater gastropods. Meleagrina. From the Greek meleagris, a guinea hen. A genus of the family of Ostracea. Membranous. Belonging or relating to membrane. Mesentery. From the Greek mesos, in the middle, and enteron, intestine. A membrane which serves to retain the intestines in their proper situation. Metamorphosis. From the Greek meta, indicating change, and morph, form, transformation. Microscopic. From the Greek mikros, little, and scopio, I view. Diminutive. Not easily seen without the aid of a magnifying glass. Mitra. Greek. A headband or diadem. A genus of gastropods. Moriolus. Latin. A bucket, a genus of mollusks. Molecule. An atom. Mollusca. From the Latin mollis, soft. Name of the second branch of the animal kingdom. Mollusk. A soft animal. Monodon. From the Greek monos, single, and oudus, tooth. A genus of the family of trochoids. Monodonta, Latin, monodons. Monomyaria, from the Greek monos, single, and one, muscle. Bivalves which only have one adductor muscle. Mucronate, ending in a sharp, rigid point. Multivalve, from the Latin multus, many, and valve, valves, composed of several or more than two calcareous species or valves. Multilocular, from the Latin multus, many, and loculus, a large. Many-chambered, consisting of several divisions. Murex, Latin, a shellfish, a genus of gastropods. Muricis, plural of murex. Muricated, clothed with sharp spines. Muscle, fleshy fibres capable of contraction and relaxation. Muscular, belonging or relating to muscle. Muscle, an acephalous mollusk. Maya, from the Greek muon, a muscle, an acephalous mollusk. Mytilacea, from the Greek mutulos, a muscle, name of a family of mollusks. Mytilus, Latin, a muscle. Nacre, from the Spanish nacar, mother of pearl. Nacreous, of the nature of mother of pearl. Nassa, Latin, a net, a snare, a genus of gastropods. Natica, Latin, name of a genus of gastropods. Nautilus, from the Greek nautilos, name of the Argonaut, a genus of cephalopods. Nemoral, from the Latin nemus, a wood, belonging or relating to a wood or grove. Nerita, Latin, a shellfish, a genus of gastropods. Neritina, Latin, diminutive of Nerita, a genus of gastropods. Nervus, belonging or relating to the nerves. Niloticus, Latin, belonging to the Nile. Nited, from the Latin nitio, I shine. Glossy, nodos, knotty. Nuca, nu-ca, the nape of the neck. Nucleus, a kernel, a centre around which matter has accumulated. Nuda, Latin, naked. Nudibranch, relating to the Nudibranchiata. Nudibranchiata, from the Latin nudus, naked, and branchia, gills. Name of an order of gastropods. Nummulitis, from the Latin nummus, money, and the Greek lithos, stone. An extinct genus of cephalopods of a thin lenticular shape, divided internally into small chambers. These occur so abundantly in some parts of the chalk formation that the name of Nummulite limestone is given to the strata so characterized. End of Glossary D-N.
Glossary O-Z of Elements of Conchology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Elements of Conchology by William Ruschenberger. Glossary O-Z. Nacreous, of the nature of mother of pearl. Nassa, Latin, a net, a snare, a genus of gastropods. Natica, Latin, name of a genus of gastropods. Nautilus, from the Greek nautilos, name of the Argonaut, a genus of cephalopods. Nemoral, from the Latin nemus, a wood, belonging or relating to a wood or a grove. Nerita, Latin, a shellfish, a genus of gastropods. Neritina, Latin, diminutive of Nerita, a genus of gastropods. Nervus, belonging or relating to the nerves. Niloticus, Latin, belonging to the Nile. Nated, from the Latin nitio, I shine, glossy. Nodos, knotty. Nuca, nu-ca, the nape of the neck. Nucleus, a kernel, a centre around which matter has accumulated. Nuda, Latin, naked. Nudibranch, relating to the Nudibranchiata. Nudibranchiata, from the Latin nudus, naked, and branchia, gills, name of an order of gastropods. Nummulitis, from the Latin nummus, money, and the Greek lithos, stone, an extinct genus of cephalopods of a thin lenticular shape, divided internally into small chambers. These occur so abundantly in some parts of the chalk formation that the name of Nummulite limestone is given to the strata so characterized. Oblongovate, egg-shaped or oval, obsolete, indistinct, not well defined. Ocellated, from the Latin oculus, an eye, marked with eye-like spots. Ochreous, ochreous, of the color of yellow ochre. Octopus, from the Greek octo, 8, and pus, foot, name of a genus of cephalopods. Octopodia, a tribe of cephalopods. Esophagal, belonging to the esophagus. Esophagus, Latin, the gullet. Offuscated, darkened, clouded, dimmed. Officinalis, Latin, officinal, from officina, a shop, applied to what is ready prepared. Oliva, Latin, an olive, a genus of gastropods. Olivaceous, being of a greenish olive color. Oncidium, a genus of gastropods. Opaque, from the Latin opacus, dark, incapable of transmitting light. Operculum, from the Latin operio, I cover, the lid or door which covers anything. Optic, from the Greek optomai, I see, the principal nerve of vision is so called. Orbicula, from the Latin orbis, a circle. A genus of brachiopod mollusks. Orbicular, spherical, circular, round. Organ, from the Greek organon, an instrument. Part of an organized being, destined to exercise some particular function. Organization, a mode of structure. Ostracia, name of a family of bivalves. Ostrea, Latin, an oyster, name of a genus of the family of Ostracea. Ovaries, female organs which contain the ova or eggs. Ovate, shaped like the longitudinal section of an egg. Oviduct, from the Latin ovum, an egg, and duco, I conduct, the tube which conveys the ovum from the ovary. Oviparous, from the Latin ovum, an egg, and pario, I produce, applied to animals whose young are produced by means of eggs. Ovoid, oval. Ovula, from the Latin ovum, an egg, a genus of gastropods. Ovulae, plural of ovula. Palatine, relating to the palate. Pallial, belonging or relating to the pallium. Pallium, Latin, a cloak. The mantle of mollusks is so called. Paludina, in the plural paludinae, from the Latin palus, a marsh, name of a genus of freshwater gastropods. Pancreas, a gland situated in the abdomen. Papilla, plural papillae, Latin, a nipple-like eminence. Papillus, papillary, having the surface covered with pimples or dots. Papillose, pimpled, dotted. Papyraceous, from the Latin papyrus, a sort of paper, thin as paper. Parietus, from the Latin parius, a wall, a name given to parts that form the enclosures, the limits of different cavities of the body. Parmacella, from the Latin parma, a round buckler, a genus of naked gastropods. Patella, in the plural patellae, Latin, the knee pan, a genus of gastropods. Patulus, with a gap or opening. Pecten, in the plural pectenus, Latin, a comb, a genus of the family of Ostracea. Pectinata, Latin, pectinated, pectinated, resembling the teeth of a comb. Pectinibranch, from the Latin pecten, comb, and branchia, gills, relating to the pectini branchiata. Pectini branchiata, name of an order of gastropods. Pectunculus, Latin, name of a genus of the family of Ostracea. Pedicle, a support, a little foot. Pediform, foot-shaped. Peduncle, a footstalk or tube on which anything is seated. Pedunculate, having a peduncle. Pelagic, belonging to the deep sea. Pellicle, a thin skin or film. Penultimate, next to the last. Perna, in the plural pernae, Latin, a gammon, a genus of the family of Ostracea. Pericardium, the sac which contains the heart. Petracola, from the Latin petra, a stone, and colo, I inhabit, name of a family of Ostracea. Fascianella, from the Greek fascianos, a peasant, a genus of gastropods. Pharynx, the swallow, the superior opening of the gullet. Pholas, in the plural, pholatis, from the Greek pholios, a lurking place, a genus of the family of Inclusa. Phosphoric, phosphorescent, emitting light in the dark. Phyllidia, from the Greek phollon, a leaf, name of a tribe of mollusks. Physa, from the Greek phusa, a bubble, a genus of freshwater snails. Pica, Latin, black as pitch. Pileopsis, from the Greek pilos, a hat, a genus of gastropods. Pillar, the internal continuation of the columella, and extends from the base to the apex. Pinna, Latin, in the plural, pinnate, a fin, a wing, a genus of the family of Ostracea. Pinnated, winged. Planorbis, from the Latin planus, flat, and orbis, an orb, a circle, a genus of marsh snails. Plica, Latin, a fold. Plicate, folded or plaited, as in the pillar of the volute tribe. Plurobranchus, from the Greek pleura, side in branchia, gills, a genus of gastropods. Plurobranchi, plural of Plurobranchus. Plumose, having a feathery appearance. Polypi, plural of Polypus. Polypus, from the Greek polos, many, and pous, foot, a genus of radiate animals. Polythalamus, from the Greek polis, many, and thalamus, chamber, having many chambers. Porcate, marked with raised longitudinal lines. Shall we go? Porcellana, Latin, porcelain. Porrected, projecting. Post-esophageal, situate behind the esophagus. Pounce, a powder to prevent ink from spreading after erasures. Prehension, the act of laying hold of and conveying the food to the mouth. Proboscis, a trunk, a prolongation of the nose. Produced, lengthened out. Samobia, from the Greek samos, sand, a genus of bivalves. Pterocera, from the Greek pteron, wing, and keras, a horn, a genus of gastropods. Pteropoda, from the Greek pteron, a wing, and pos, foot, name of a class of mollusks. Punctuated, from the Latin punctum, a point, having small hollows like the punctures of a thimble. Pulmonary, belonging or relating to the lungs. Pulmonea, Latin, pulmonary. Pupa, Latin, a puppet, a genus of snails. Purpura, Latin, purple, a genus of the family of buccinoids. Pylorus, the right orifice of the stomach. Piriform, pear-shaped. Plural, Pyrosome, from the Greek par, fire, and soma, body, a genus of mollusks. Quadrangular, having 4 angles. Quadriplicated, having 4 plates. Radiata, Latin, name of a class of zoophytes. Radiate, from the Latin radius, a ray, furnished with rays. Rectum, the terminating portion of the intestine. Recurved, bowed back. Reflected, bent backwards. Refracted, abruptly bent as if broken. Reinformed, kidney-shaped. Repand, with a serpentine margin. Replicated, folded so as to form a groove or channel. Respiration, the act or function of breathing. Respiratory, relating to respiration. Reticulated, formed like a piece of network. Retractile, susceptible of being drawn back. Retroflected, bent backwards. Retrus, backed up, turned up. Retroverted, turned back. Retus, ending in an obtuse sinus. Retundated, blunted or tanned at the edge. Revolute, rolled backwards. Rima, the interstice between the walls when the hymen is removed. Rostrum, the beak, the extension of that part of the shell in which the canal is situated. Rotund, round, circular, spherical. Rufous, of a reddish colour. Rufus, Latin, reddish. Rugose, rugged, full of wrinkles. Saliva, the fluid secreted in the mouth by the salivary glands. Salivary, relating to saliva. Sanguinolaria. From the Latin, sanguis, blood. Name of a genus of acephalous mollusks. Sanguinaceous, of a blood colour, or resembling blood. Scabrous. From the Latin scaber, rough. Rough, harsh, rugged, or like a file. Scalaria. From the Italian scala, a ladder or series of stairs. Name of a genus of gastropods. Scalloped. Indented at the edges. Sclerotica. From the Greek skleros, hard. One of the external membranes of the eyeball. Scorbiculate. Pitted, having the surface covered with hollows. Scutilated, scutiform, shield-shaped. Scutibranchiata. From the Latin scutum, a shield, and branchia, gills. An order of gastropods. Seam. The line formed by the union of the walls. Secondary formation. A series stratified rocks which certain characters by which they are distinguished from the primary rocks. By the term formation, geologists understand a series of rocks of the same age. Those rocks which were first formed are called primary, those formed next in succession are secondary, and so on. Secretion. From the Latin secernere, to separate. The process by which organic structure is enabled to separate from the fluid circulating in it other different fluids. These separated fluids are also called secretions. Secretory. Belonging or relating to secretion. Semicorneous. From the Latin semi, half, and cornu, horn. Half or partly horny in its nature. Sepia. Latin. A cuttlefish. A kind of paint made from this animal. A genus of cephalopods. Septiform. From the Latin septum, a partition. In the shape of a partition. Serrated. From the Latin serra, a saw, like the teeth of a saw. Serrated. Very minutely serrated. Seta. Latin. A bristle. Setaceous. Setose. Bristly, covered with bristles. Cigarettus. A genus of gastropods. Silicaria. From the Latin silica, a pod. A genus of gastropoda. Sinister, the left. Sinus. A groove or cavity. Siphonaria. From the Greek siphon, a tube. An order of cephalopods. Siphunculus. A cylindrical canal perforating the partitions in polythalamus shells. Solar. From the Latin sol, the sun. Belonging or relating to the sun. Solarium. Latin. A sundial, a genus of family of trochoids. Solemia. A genus of the family of Inclusa. Solen. From the Greek solen, a tube, a genus of acephalous mollusks. Spatulate. Rounded and broad at one end, and becoming narrow like a battledore or a spatula. Spheroidal. Resembling a sphere or globe. Spinal. Belonging or relating to the spine. Spinous, spiny. Covered with thorn-like processes or spines. Spire. All the whorls of univalve shells, except the one in which the aperture is situated, which is termed the body. Spiral. Twisted like a corkscrew. Spleen. An organ of the body, the use of which is not known. It is vulgarly called the melt. Spondylus. In Greek, spondylos, a vertebra. A genus of bivalves in which the teeth of the hinge lock into each other like the vertebrae of the spine. Squamose. From the Latin squama, a scale, scaly. Stellated. Consisting of star-like figures. Strata. Latin. Plural of stratum. Stratum. Latin. A bed, a layer. Stria. Latin. In the plural, striae. A diminutive channel or crease. Striated. Scored or covered with fine thread-like lines. Strombus. Latin. In Greek, strombos, a shellfish. A genus of gastropods. Stylet. A small style or slender process. Subarcuated. Somewhat arched. Subconic. Somewhat conical. Subesophageal. Placed beneath the esophagus. Subrotund. Nearly globular. Subulate. Awl-shaped. Succinia. From the Latin succinum, amber. A genus of gastropods, so called from the transparent texture and amber color of the shell. Sulcated, furrowed. Sulci, plural of sulcus. Sulcus, Latin, a furrow. Summit, the tip or apex. Superficies, from the Latin super, above, and facies, face, the surface. Superposed, from the Latin super, above, and pono, I place, land one upon another, lying above. Suture, the seam or fine spiral line which separates the whorls or rets. Siphon, from the Greek siphon, a tube. Tact, the sense which gives the perception of touching. Touch is active, tact is passive. Tectibranchiata, from tego, eye cover, and branchia, gills. Name of an order of gastropods. Tegumentary, relating to the tegument or covering. Telina, in the plural telinae, from the Greek telene, a species of mussel, a genus of acephalous mollusks. Tentacle, a feeler. Tentacula, the feelers of snails. Tentacular, belonging or relating to tentacles. Tentaculum, Latin, a feeler. Terebra, Latin, from terebra, I bore. A genus of gastropods. Terebratula, plural. Terebratulae, a genus of acephalous mollusks. Teredo, Latin, a shipworm. Teredinus, plural of teredo. Terrestria, Latin, terrestrial. Tertiary formation or strata, a series of sedimentary rocks which lie above the primary and secondary strata and distinguished from them by their organic remains. Tessellated, checker like a chessboard. Tessellatus, Latin, tessellated. Testacea, from the Latin testa, a shell, an order of acephala covered with testaceous shell. Testaceous, consisting of carbonate of lime and animal matter. Testacella, a genus of snails. Tetrabranch, having 4 branchiae. Tetrabranchiata, from the Greek teteros, 4, and branchia, gills. Name of an order of gastropods. Tetragonal, 4-cornered. Thoracic, belonging to the thorax. Thorax, Latin, the chest. Transverse, placed crosswise. When the breadth of a shell is greater than its length, it is termed transverse. Trapeziform, shaped like a trapezium. Tridacna, a genus of the family of Chamachia. Tricornis, from the Latin tres, 3, and cornu, horn, 3-horned. Trigonia, from the Greek trigonus, 3-cornered. A genus of the family of Ostracea. Trigonal, 3-cornered. Tritonia, a genus of gastropods. Trochoides, from the Greek trokos, a wheel, and eidos, resemblance. Name of a family of gastropods. Trochi, plural of trochus. Trochus, trocus, a genus of gastropods. Trunk, the body. Truncate, stunted, cut short, or abruptly off at the end. Tubercle, a little knot or pimple. Tuberculated, knotted or pimpled. Tuberosities, prominent knobs or excrescences. Tubular, in shape of a hollow tube. Tubulate, hollow. Tubulibranchiata, from the Latin tubus, tube, and branchia, gills. An order of gastropods which have the branchiae lodged in a tube. Tunicata, name of an order of acephalous mollusks. Tunicate, from the Latin tunica, a tunic. Coated. Turbinated, shaped like a top or pear. Turgid, swollen. Turreted, resembling a tower with turrets. Turbo, Latin, a whirling or twisting. A tribe of gastropods. Turritella, Latin, a turret. A genus of gastropods. Umbilicus, the aperture or depression in the center around which the shell is convoluted. Umbilicated, having a depression in the center like an umbilicus. Umbo, Latin, a protuberance or boss. The round part of a bivalve shell which turns over the hinge. Umbones, plural of umbo. Umbonate, boast, having a raised knob in the center. Unarticulated, not jointed. Undatum, Latin, waved. Undulated, waved, having a waved surface. Unilocular, from the Latin unus, one, and loculus, partition, having a single chamber or compartment. Unio, Latin, a pearl, a genus of mussels. Uniones, plural of unio. Univalve, consisting of one piece or valve. Urceolate, swelling in the middle like a pitcher. Vaginilla, Latin, a little sheath or scabbard, a genus of naked gastropods. It's the same as the Vaginillus. Valvata, a genus of freshwater snails. Varices, longitudinal ribs and univalve shells. Vascular, composed of numerous vessels. Vaulted, arched like the roof of the mouth. Vena, Latin, a vein. Venous, relating to vein. Venter, Latin, belly, the most prominent part of the shell when the aperture is turned towards the observer. Ventral, relating to the belly. Ventricose, inflated, swelled in the middle. Ventricle, a little belly, a part of the heart. Veneripis, a genus of Cardiacea. Venus, a genus of the family of Cardiacea, a genus of gastropods. Vermiform, worm-shaped. Verrucose, from the Latin verruca, a wart, warted. Vertebra, from the Latin vertere, to turn, a joint or bone of the backbone or spine. Vertebral, relating to the vertebrae. Vertebrata, name of the first branch of the animal kingdom. Vertebrate, having vertebrae. Verticulated, whorled. Vesicle, a diminutive bladder. Vesicular, relating to vesicles. Viscous, any internal part as the heart, intestine, etc. Viscera, plural of viscous. Visceral, relating to viscera. Viscid, glutinous, sticky. Vitreous, resembling glass. A humour of the eye is so termed. Vitrina, from the Latin vitrea, glass, a genus of freshwater gastropods. Voluta, Latin, a whorl, a genus of gastropods. Vulgaris, Latin, common. Whorl, a wreath or turning of the spire of univalve shells. Zoned, surrounded with one or more girdles. Zoology, from the Greek zoon, animal, and logos, discourse, the science of animals. Zoophyte, from the Greek zoon, animal, and phuton, plant, an animal belonging to the fourth division of the animal. End of Glossary O-Z. End of Elements of Conchology by William Ruschenberger.